There is a place in the universe where nothing exists. Not a place where stars have burned out. Not a place where galaxies have drifted apart over billions of years. A place where, as far as we can tell, almost nothing was ever there to begin with. No light, no warmth, no motion. Just an expanse of space so vast, so empty, so profoundly silent that the very idea of it presses gently against the edges of what the human mind can hold. Tonight, we are going there. Before we do, I want you to settle in. Let your body find its weight. Let your shoulders release whatever they have been carrying today. If you have a blanket nearby, pull it a little closer. If the room is dark, let it be dark. Because the place we are traveling to tonight asks something of you that most. Journeys do not ask. It asks you to become comfortable with emptiness. It asks you to sit with silence not as an absence of something good, but as a presence of something vast and ancient, and in its own strange way, beautiful. The place is called the Eridanus Supervoid, and it is, without question, one of the strangest things we have ever found. In the universe, you may have heard of voids before. Cosmic voids, regions of space where galaxies are sparse, where the great web of the universe thins out into something closer to emptiness. Most of them are large by any human standard, tens of millions of light years across, sometimes more. But the Eridanus Supervoid is something else entirely, something that makes other voids feel almost cozy by comparison, something that stretches across approximately 1 billion light years of space and contains, within that staggering volume, almost nothing at all. 1 billion light years. Let that phrase rest in your mind for a moment, without trying too hard to understand it. Just let it sit there, the way you might sit beside an ocean at night, not trying to count the waves, just feeling the vastness of the water, stretching beyond where your eyes can reach. 1 billion light years. We will spend time with that number later, turning it over slowly, finding ways to feel its edges even if we can never truly grasp its full size. But for now, just know that it is large beyond any ordinary sense of the word. And it is empty. The universe, as you may know, is not a smooth or uniform place. If you could somehow zoom out far enough to see it all at once, you would not see a soft, even glow of matter spread equally in every direction. You would see something far more textured, far more dramatic. You would see a cosmic web, a vast network of filaments and walls, threads of galaxies connecting like the strands of a spider's web stretched across unimaginable distances. Where those threads cross and thicken, you find clusters, dense neighborhoods of hundreds, or thousands of galaxies pulled together by gravity, blazing with light. Between the threads, you find voids, the dark spaces, the hollow bubbles of relative emptiness that give the web its shape. It is a universe built as much from absence as from presence, and that, in itself, is worth pausing to consider. But even within this web, even knowing that emptiness is part of the pattern, the Eridanus Supervoid stands apart. It is not simply a gap between threads. It is a region so large, so devoid of the structures we expect, that when scientists first began to seriously examine it, some of them struggled to explain how it could exist at all, not just in practical terms, but in theoretical ones, not just as a curiosity, but as a challenge to some of our most carefully constructed ideas about how the universe formed and why it looks the way it does. We will get to all of that. We have time. Tonight is long, and the void is patient. For now, I want you to imagine something simple. Imagine you are standing somewhere very quiet. Perhaps it is a field at night, far from any city, the kind of place where the silence has texture and depth. Or perhaps it is the middle of a forest in winter, where snow has muffled every sound and the air is so still it feels almost solid. Or perhaps it is the bottom of a valley, just before dawn, when the world has not yet remembered how to make noise. Now, imagine that silence stretched not for meters, not for kilometers, not even for the length of a country or a continent. Imagine it stretched for a billion light years. Imagine that the quiet you feel in that field, in that forest, in that valley, was the same quiet that existed in every direction for distances so enormous they swallow time itself. That is the Eridanus Supervoid, and we are going to spend this night inside it. Not in a frightening way, not in the way of nightmares or cold sweats. We are going there the way you might travel in a dream, gently, with curiosity, with the particular kind of peace that comes from knowing you are safe and warm. While your mind wanders somewhere extraordinary, we are going there because emptiness, it turns out, has things to teach us. About the universe, yes, but also about ourselves. About what we find when we stop filling silence with noise and simply listen. The Eridanus Supervoid was not always known to us. For most of human history, we did not even know it existed. And that is remarkable in itself. To think that for thousands of years of stargazing, of mythology and navigation, and wonder, of all the stories we told about the sky, there was this enormous hole in the universe, hiding in plain sight, unnamed and unnoticed. Of course, it was hiding not because it was obscured, but because it was empty. And empty things are always harder to see than full ones. You notice the star, not the darkness between stars. You notice the galaxy, not the billion light years where no galaxy lives. Absence requires a different kind of attention, a slower kind, the kind we are practicing right now as your breath deepens and the world outside this moment grows a little quieter. There is a constellation called Eridanus. It is one of the largest constellations in the night sky, named for a river, a long, winding river that ancient astronomers traced among the stars. In Greek mythology, Eridanus was the river into which Phaeton fell when he lost control of the sun's chariot, and Zeus struck him down with a thunderbolt. A river of light, a river of tragedy, a river that wound its way through the sky like a path into somewhere deep and unknown. The Supervoid shares its name with this river because it lies in that direction in the sky, behind the constellation, far beyond any star we can see. With the naked eye, past distances that would take light itself hundreds of millions of years to cross, the void waits. It is not visible to any naked eye, not to any small telescope, not even to most large ones without very specific things to look for. It announces itself not with light, but with the absence of light, not with presence, but with a gap in what should be there. And what should be there, according to everything we understand about the universe, is galaxies. Thousands of them, tens of thousands, perhaps, bright islands of stars and gas and dust and ancient light strung along the filaments of the cosmic web like lanterns in the dark. But in the Eridanus Supervoid, they are not there. Or if they are so few, so faint, so scattered, that their presence barely registers against the overwhelming silence of the void itself. Tonight, we will ask why. We will explore what science knows, what it suspects, and what it genuinely cannot yet explain. We will meet the few faint galaxies that do exist inside this desert, and we will wonder what it might feel like to be there. We will travel with an imaginary companion, a traveler, crossing this void, and we will feel through their eyes and their long, patient journey what it means to move through a place where almost nothing is. And somewhere along the way, I hope the emptiness itself will become something restful, something that carries you down into sleep the way a river carries a leaf, gently, without urgency, towards somewhere deep and still. So let your eyes close if they want to. Let your breathing slow. The void is not going anywhere. It has been there for billions of years, and it will be there long after tonight. We have all the time we need. Welcome to the Eridanus Supervoid. Welcome to the silence. Every map tells two stories. The first story is the obvious one. What is there? The mountains, the rivers, the cities, the roads. The features that rise up and announce themselves, that demand to be drawn and labeled and remembered. This is the story most people read when they look at a map. They trace the lines, find the landmarks, follow the routes from one place to another. But the second story is quieter and in some ways more important. It is the story of what is not there. The blank spaces, the uncharted regions, the places where the mapmaker ran out of information and left the page empty. For centuries, those blank spaces were where dragons lived, where the unknown pressed against the known, where imagination was invited to fill what observation had not yet reached. Astronomers are mapmakers too, but their maps are not of land or sea. Their maps are of something far larger and far stranger. They are maps of the universe itself, of the distribution of galaxies across billions of light years of space. And when they began drawing those maps in earnest in the latter half of the 20th century, they found something that no one had quite anticipated. They found a map with a very large hole in it. To understand how that hole was found, it helps to understand how the maps were made in the first place. For most of human history, the universe, as far as anyone knew, was the Milky Way. Our galaxy, our island of hundreds of billions of stars, was thought to be everything. The faint smudges visible through early telescopes, the nebulae, were assumed to be clouds of gas within our own galaxy, neighbors in the same great structure. It was not until the 1920s that Edwin Hubble, working with the Great Telescope at Mount Wilson Observatory, demonstrated that some of those smudges were not nebulae at all. They were galaxies, entire islands of stars separated from us by distances so vast that light itself needed millions of years to make. The crossing, the universe, in a single decade, expanded beyond anything previously imagined. Our Milky Way was not the universe. It was one galaxy, among what would turn out to be hundreds of billions. Once that was understood, the next question followed naturally. How are all those galaxies arranged? Are they scattered randomly, like grains of sand, thrown across a beach? Or is there some pattern, some structure, some shape too? The way matter has distributed itself across the cosmos. The answer, it turned out, was structure. Profound, beautiful, and deeply unexpected structure. Galaxies are not scattered randomly. They gather into clusters, pulled together by their mutual gravity. Clusters gather into superclusters, and superclusters arrange themselves along vast filaments, threads of matter that stretch for hundreds of millions of light years, connecting and weaving together into what scientists came to call the cosmic web. Seen from far enough away, the universe looks something like a sponge or like the delicate foam that forms when ocean waves collapse on a shore. Dense, glowing strands of galaxies enclosing great dark bubbles of emptiness. To draw this map, astronomers needed to measure not just where galaxies appeared in the sky, but how far away they were. And for that, they used a remarkable tool built into the fabric of the expanding universe itself. As the universe expands, light traveling through it gets stretched. The longer the journey, the more the stretching. This stretching shifts the light toward the red end of the spectrum, a phenomenon called redshift. By measuring how much a galaxy's light has been redshifted, astronomers can calculate how far away it is, and therefore where it sits in three-dimensional space. Survey by survey, galaxy by galaxy, the map was built, and as it grew, patterns emerged. Great walls of galaxies, long filaments, deep voids. The universe revealed itself to be not a smooth, uniform place, but a richly textured one, full of contrast between the dense and the sparse, the bright and the dark. It was in this context that astronomers began to pay attention to a particular region of the sky. The constellation Eridanus lies in the southern portion of the celestial sphere, a long, winding constellation named for a mythological river. Behind it, at distances of hundreds of millions to billions of light years, the galaxy surveys were revealing something troubling, a region where the expected density of galaxies was not met, where the map grew thin, and then thinner still, and then, by any reasonable measure, almost blank. The first hints came from various galaxy surveys in the late 20th century, as redshift data accumulated and the three-dimensional picture of the universe in that region began to take shape. But the most dramatic signal came not from a galaxy survey at all. It came from the sky itself, from the faint afterglow of the Big Bang, the ancient light that still fills the universe from every direction, a relic of the moment, 380,000 years after the beginning, when the universe first became transparent. This ancient light is called the cosmic microwave background. It is one of the most important objects of study in all of cosmology. It is the earliest picture we have of the universe, a snapshot taken when everything was still, young and hot and dense, and when satellites began mapping it with extraordinary precision. They found something unexpected, a region of the sky where the temperature of this ancient light was slightly cooler than it should have been, significantly cooler. A cold spot, as scientists came to call it, sitting in the direction of the constellation Eridanus. Cold spots in the cosmic microwave background are not unheard of. Tiny fluctuations exist everywhere, the seeds of all the structure that would later grow into galaxies and clusters. But this cold spot was different. It was too large and too cold. It was an outlier, something that did not fit easily into the standard picture. And as scientists investigated, they found that the cold spot lined up in a striking and suggestive way with the region of space that the galaxy surveys had flagged as unusually empty. The Eridanus Supervoid and the cold spot seemed to be connected, two different ways of seeing the same remarkable thing, an enormous region of the universe that was, by any measure, profoundly different from its surroundings. Now, this is the moment to pause and appreciate what we are really talking about. A map with a hole in it is one thing when the map is of a forest or a coastline, but this is a map of the universe. The hole in it is approximately 1 billion light years across. If you were to place our entire Milky Way galaxy at one edge of this hole and set off toward the other side traveling at the speed of light, the fastest speed anything in the universe can achieve, you would not arrive for 1 billion years. Not 1 million, 1 billion. The mapmakers who found this hole did not quite know what to make of it. In some ways, large voids are expected. The cosmic web is full of them, the hollow spaces between the filaments. But a void of this size, of this depth, of this apparent severity of emptiness was harder to account for. It pushed against the edges of what the standard models of cosmology predicted should be possible. The question that the hole posed was simple, but its answer was anything. But why is it there? We will spend much of this night exploring that question. But for now, I want you to sit with the image of that map, that great, detailed, intricate tapestry of the universe, with its glowing filaments and dense clusters and countless galaxies. And somewhere in that tapestry, a hole, not a small hole, not a modest gap, a hole so large that it takes light 1 billion years to cross, a hole so empty that it changes the temperature of ancient light as that light passes through it, a map with a hole in it. And on the other side of that hole, on the edges where the galaxies begin, again, something that might be wonder, or might be unease, or might be both at once. The feeling you get when you realize the map is telling you something it does not quite know how to say, something it can only show you by pointing at the blank space and saying, here. Here is where we do not know. Here is where the universe keeps a secret. Let that image carry you a little further into the quiet. The map is vast, and the hole is vast, and the night is long. There is no hurry. The void has been waiting for 1 billion years. It can wait a little longer while you breathe and rest and let your mind wander gently toward the edge of the known. Numbers have a strange quality. At small scales, they feel real. 3 apples, 7 steps, 40 years. We can count to these. We can hold them. We can feel their weight in our hands or in our memories. But as numbers grow, something happens. They begin to lose their grip on the tangible. 1 million of anything starts to feel abstract. A billion feels almost like a fiction. And when you place the word light, years after billion, you have left the country of comprehension entirely and entered somewhere else. Somewhere that language reaches, for but cannot quite touch. So let us go slowly. Let us try. A light year is not a measure of time. It is a measure of distance. Specifically the distance that light travels in 1 year. Light moves at approximately 300,000 kilometers per second. In 1 second, it could travel around the Earth more than 7 times. In 8 minutes, it crosses the distance from the Sun to the Earth. In about 4 years, it crosses the distance to our nearest neighboring star. In 1 year, light covers approximately 9.5 trillion kilometers. 9.5 trillion. That single number is already beyond ordinary imagination, but it is only 1 light year, and the Eridanus Supervoid is 1 billion light years across. Let us try to build a bridge between those 2 scales. Imagine our Milky Way galaxy. It is a spiral of stars, gas, and dust, roughly 100,000 light years from one edge to the other. If you were to travel at the speed of light across the full width of our galaxy, the journey would take 100,000 years, not 100 years, not 1,000, 100,000. In that time, entire civilizations could rise and fall. Languages could be born and go extinct. Mountains could erode too. Plains. And you would still be inside our own galaxy, still crossing the single island of stars that we call home. Now, the Eridanus Supervoid is 1 billion light years across. That means you could line up 10,000 Milky Way galaxies end to end, and that line would just barely span the width of this void. 10,000 galaxies. 10,000 100,000 light-year journeys, placed one after another like rungs on an infinite ladder. And at the end of all that, you would be at the other side of a space that contains almost nothing. Nothing to stop you, nothing to distract you, nothing to mark your progress, except the slow, patient passage of time and the darkness that does not change and the absence that stretches on and on and on. There is another way to feel this scale. Think about time. The universe is approximately 13.8 billion years old. That is the age of everything, from the first moment of the Big Bang to this present night, wherever you are, whatever time it is as you listen to these words. The light crossing the Eridanus Supervoid would take 1 billion years to make that crossing. That is more than 7% of the entire age of the universe, used up in the act of crossing one empty region of space. Light that began its journey when complex life on Earth was only beginning to dream of skeletons, and shells would still be traveling, still moving through the dark, still not yet at the other side. Or consider this: when that light began its crossing, the creatures we would eventually call dinosaurs had not yet appeared on Earth. The great age of Reptiles was hundreds of millions of years in the future. The continents were arranged differently. The oceans were different. The sky was different. And yet, a photon of light that set off across the Eridanus Supervoid at that moment would, by today, still not have finished crossing it. This is not meant to overwhelm you. I say it slowly, gently, because there is something almost meditative about numbers this large. They do not crush you. They lift you out of the small, the immediate, the ordinary. They remind you that the universe is under no obligation to fit within the scale of human experience. It is what it is, vast and patient and indifferent to whether we can comprehend it. And there is a strange peace in that, if you let it come. The 1 billion light-year width of the Eridanus Supervoid is, to be precise, an estimate. Measurements of voids are not like measurements of a table or a room. You cannot put a ruler against a void. You can only infer its edges from where the galaxies begin to appear with something approaching normal density. And since the void does not have a sharp boundary, since it fades gradually from almost empty to less empty to normally occupied, its exact size depends somewhat on how you define empty. But by any reasonable definition, the Eridanus Supervoid is enormous. Some measurements put it closer to 900 million light-years across. Others suggest it may be even larger than a billion. The exact number shifts slightly as new data comes in and as scientists refine their methods. But the essential fact remains constant. This is one of the largest structures, or rather one of the largest absences of structure ever discovered in the observable universe. To put that in the context of the observable universe itself, the entire observable universe, the sphere of space that light has had time to reach us from since the Big Bang, is about 93 billion light-years across. The Eridanus Supervoid takes up roughly 1% of that diameter. 1% sounds small, but when the total is 93 billion light-years, 1% is still 930 million, still almost a billion, still staggering, and it is nearly empty. The word nearly matters. The void is not perfectly devoid of matter. There are some galaxies within it, scattered thinly across that immense volume like a handful of dust thrown into an empty sports stadium, where you might expect to find tens of thousands of galaxies in a region this size. Based on the average density of the universe, you find far fewer. The void is not absolute, but it is close enough to absolute that the distinction feels almost philosophical. Think about what it means for space to be that empty. In ordinary regions of the universe, the gap between neighboring galaxies might be measured in millions of light-years, large by human standards, but not unreachable in the context of cosmology. In the Eridanus Supervoid, the distances between the rare galaxies that do exist there are far greater. Each one is an island not just in a sea, but in an ocean that stretches for hundreds of millions of light-years, in every direction without another island in sight. If you lived on a planet orbiting a star inside one of those galaxies, and you looked out into the universe with the most powerful telescopes imaginable, you would see almost nothing. The sky beyond your own galaxy would be dark in a way that ours is not. We see thousands of galaxies scattered across the deep sky. You would see almost none. The universe would look empty, terrifyingly, profoundly empty. And you might wonder, as your civilization grew and developed, and reached for the stars, whether you were the only ones, whether there was anyone else out there in that vast dark. You would have no way of knowing that beyond the void, beyond hundreds of millions of light-years of near nothingness, the rest of the universe was teeming with galaxies, that there were clusters and superclusters, walls and filaments, billions upon billions of stars. You would be like someone standing In the middle of the Sahara on a moonless night, unable to see any light from any city, convinced perhaps that no cities existed anywhere. The scale of the Eridanus Supervoid does not just challenge our sense of space. It challenges our sense of what is possible. When scientists first began to seriously measure it, some of them found themselves troubled by its size. Not emotionally, but theoretically. Our best models of how the universe formed and evolved, of how matter distributed itself under the influence of gravity and dark energy and the initial conditions of the Big Bang, do not easily produce a void this large. The math works against it. The probabilities resist it. We will explore that trouble in detail later. For now, just feel the number 1 billion light years. Let it settle into your breathing. Let it expand outward from wherever you are lying, in whatever warm and quiet place you have found tonight, past your walls, past your street, past your city, past the curve of the earth and the orbit of the moon, past the sun and the planets, past the nearest stars, past the edge of the Milky Way, past the nearest clusters of galaxies, past the filaments and walls of the cosmic web, until it reaches a place where everything goes quiet, where the universe thins out into something close to nothing. That is where we are going. That is the Eridanus Supervoid. And the night is just beginning. Imagine someone standing at the edge, not a scientist, not an astronomer, though they carry knowledge of what lies ahead, just a traveler, a person with a long journey in front of them, and the particular kind of courage that comes not from fearlessness, but from curiosity. The kind of person who, when told that something immense and strange lies in a certain direction, feels the pull of it rather than the repulsion. They are standing at the boundary of the Eridanus Supervoid. Behind them, the universe looks familiar. There are galaxies here, glowing, with the light of billions of stars. Some are spirals, their arms sweeping through space like the slow turning of a great wheel. Some are ellipticals, older and rounder, clouds of ancient stars no longer forming much that is new. Between them, faint threads of gas and dark matter connect and weave. It is not crowded, not by any human standard. The nearest galaxy might be millions of light years away, but by the standards of the void they are about to enter, this is abundance. This is fullness. The traveler turns and looks forward. The change is not dramatic. It is not a wall, not a cliff, not a sudden sharp edge where light stops and darkness begins. The void announces itself. Gradually, the way fog thickens, the way a conversation goes quiet. The galaxies grow fewer. The threads of the cosmic web grow thinner. The light, already dim at these distances, dims further. And then, after a while, there is simply less of everything. Less light, less structure, less density. The universe, in this direction, is becoming something closer to empty. The traveler takes their first steps in. At first, they keep looking back. The galaxies behind them are still visible, though growing distant. Faint smudges of light at enormous remove. There is something comforting about them, even at this distance. They are evidence that the universe is still there, still full of its ordinary abundance. They are a kind of reassurance, not so different, perhaps, from looking back at the coast as a ship moves out to sea. The land is still there. You can still see it. You are not yet alone. But the traveler moves on, because that is what travelers do. And slowly, the galaxies behind them fade. Not all at once, not in any single dramatic moment. Just gradually, gently, the way stars fade at dawn. One by one they pass below the threshold of visibility. The smudges of light grow, fainter, then absent. And ahead, there is nothing. There is space, of course. Space is always there. But space without galaxies, space without the great structures that ordinarily populate it, has a different quality. A different, Wait, a different silence. This is the beginning of the void. Let us think for a moment about what the traveler sees, or rather, what they do not see. In ordinary space, even the dark regions between galaxies, there are stars. Not many, not close together, but stars. Stray stars that have been flung out of their galaxies by gravitational interactions, wandering in the intergalactic medium. They are not common, but they exist. They mark the emptiness with occasional faint points of light, reminders that matter has been here, has passed through. Inside the void, even these are scarce. The traveler looks in every direction and finds darkness. Not the comfortable darkness of a night sky still, salted with stars. A deeper darkness. A darkness that does not yield to looking, that does not resolve into detail the longer you stare. A darkness that is simply itself, complete and patient and without end. The traveler has a clock, because travelers tend to bring clocks, and because even in the void, time passes. And as they move through this emptiness, weeks become months, months become years, years become centuries, centuries become millennia. They are traveling at a significant fraction of the speed of light, because if they were not, the journey would take not millions of years, but billions. Even so, the crossing of this void will take an almost incomprehensible length of time. After what would be the equivalent of millions of years of travel, the traveler stops and looks around. Nothing has changed. There are no new landmarks, no features to orient by. The darkness in front of them looks exactly like the darkness behind them, exactly like the darkness to the left and to the right and above and below. The void is isotropic, meaning it looks the same in all directions. There is no up, no down, no north, no south. There is only the even, patient, featureless dark. This is the first strange thing about the void. Its sameness, its refusal to be varied or interesting in the way that familiar space is. In the galaxy-rich regions of the universe, there is always something to look at. Always some new structure at a different distance, some new angle on a familiar cluster, some faint smudge that might resolve into a galaxy if you look long enough. The universe in those regions is busy. It gives the eye and the mind something to do. The void takes that busyness away. It offers instead a kind of enforced stillness, a stripping away of stimulus. And this, depending on your temperament, can feel like one of two things. It can feel like deprivation, like a room with no windows and no furniture and no sound. Or it can feel like something else, something that has no simple name in ordinary language. The feeling of being in the presence of something very large and very quiet. The feeling that might come over you, perhaps if you were somehow suspended in the middle of a perfectly calm ocean, far from any shore, on a perfectly clear night, and you simply floated and breathed and let the stillness settle around you. The traveler does not panic. They are the kind of person who does not panic. They float in the dark and let it be what it is. And they notice something. The darkness of the void is not quite the same as the darkness of, say, a closed room. A closed room is dark because light cannot reach it, but it is still full of air, of walls, of the presence of the room itself. The void is dark because there is nothing nearby to emit light, but it is not nothing. It is space, and space, even empty space, is not nothing. It has properties. It has a temperature just barely above absolute zero, the temperature of the cosmic microwave background radiation that fills the entire universe uniformly. It has quantum fields, the strange substrates of modern physics that underlie all matter and energy, still present and still fluctuating even where no particles seem to be. The void is empty of galaxies, but it is not empty of everything. And this, the traveler thinks, is an important distinction. Emptiness is not the same as nothing. This void is not an absence of existence. It is a kind of existence, stripped to its minimum, down to almost nothing, but not quite. Not quite. Those two words will matter. We will return to them. For now, the traveler moves on. They have barely started. The void ahead of them stretches for distances that make the mind reel. They have entered a space that will not change for hundreds of millions of light years. There will be no new features, no new textures, no signposts. Only the dark and the slow passage of time and the question that begins to form somewhere in the back of their mind, quiet but persistent, like a sound at the edge of hearing. What is this place? Why is it here? How can the universe allow such emptiness? These questions have no easy answers, but they are the right questions. They are the questions that pull the traveler forward through the dark, that make the journey worth making even when, in every direction, there is nothing to see. Something about this emptiness feels ancient, even by cosmic standards, as though this region of space has been quietly waiting, has been less than the rest of the universe for a very long time, as though it has always been the quiet part, the resting place, the breath held between words. The traveler breathes too, there in the dark, and they keep going. And we, here in our warm and quiet places, follow them at a distance, through the thin and patient medium of imagination. We are safe where we are, but we can feel the void through them. We can let its scale press gently against our sense of the ordinary. We can let it remind us that the universe contains not only the brilliant and the full, but also the quiet and the almost empty, and that both are real, and that both, in their own way, are beautiful. To find something by its absence is one of the harder things science is asked to do. When you are looking for a star, you point your telescope and you look for light. When you are looking for a galaxy, you search for the faint smudge of light that billions of stars make when they are far enough away to seem almost like a single point. Light is what our instruments are designed to detect. Light is how the universe announces itself to us. We are, in a fundamental sense, creatures of light, evolved to gather it and make sense of it, dependent on it in ways both practical and philosophical. But the Eridanus Supervoid announces itself with darkness, with an absence of the light that should be there but is not. To find it required a particular kind of attention, a willingness to measure what was missing rather than what was present. And the path to its discovery was, in many ways, as remarkable as the void itself. The story begins not with a telescope pointed at a galaxy, but with a satellite pointed at the entire sky. In 2001, NASA launched the Wilkinson microwave anisotropy probe, known by the much more manageable name of WMAP. Its mission was to map the cosmic microwave background with a precision that had not been possible before. That ancient light, the afterglow of the Big Bang, the faint hiss of the universe's first 380,000 years, was already known to be nearly uniform across the sky. But nearly is not the same as perfectly, and in the tiny fluctuations from that near uniformity, WMAP was designed to read the story of the universe's earliest structure. The cosmic microwave background is one of the most important things we know about. It is the earliest direct evidence we have of the universe, a snapshot, taken when everything was still young and hot and dense, and when satellites began mapping it with extraordinary precision. They found something unexpected, a region of the sky where the temperature of this ancient light was slightly cooler than it should have been, significantly cooler. A cold spot, as scientists came to call it, sitting in the direction of the constellation Eridanus. Cold spots in the cosmic microwave background are not unheard of. Tiny fluctuations exist everywhere, the seeds of all the structure that would later grow into galaxies and clusters. Most of them fall within the range that the standard model predicts. But this one was different. It was larger than expected and colder than expected. It was, in the technical language of cosmology, anomalous. Anomalies are gifts to science. They are the places where the map does not match the territory, where reality declines to conform to expectation, where something new might be lurking. An anomaly means that either the model is wrong, or the measurement is wrong, or there is something in the universe that the model does not yet account for. All three possibilities are worth investigating, and all three were investigated here. One of the explanations that scientists considered was the possibility of a supervoid, an unusually large and unusually empty region of space located between us and the surface of last scattering, the ancient sphere from which the cosmic microwave background light is arriving. The idea was based on a physical effect called the integrated Sachs-Wolf effect. As light passes through a region of space, the gravitational environment of that region can affect it. In a region of normal density, the light falls into a gravitational well and then climbs out, and in an expanding universe, these effects largely cancel. But in a very large void, the gravitational well is shallower than normal, and as the universe expands while the light is crossing the void, the cancellation is incomplete. The light loses a small amount of energy. It arrives at the observer slightly cooler than it would have otherwise. A supervoid, in other words, could leave a cold imprint on the cosmic microwave background, and the cold spot in the direction of Eridanus was, in principle, consistent with this effect. But to test this, scientists needed to look at the actual distribution of galaxies in that direction. They needed to compare the galaxy map with the temperature map and see if the emptiness and the coldness lined up. And so began the work of galaxy surveys focused on the Eridanus region, painstaking observations that built up a three-dimensional picture of what existed and what did not exist in the direction of that anomalous cold spot. What they found confirmed the suspicion. In the direction of the cold spot, there was indeed a region of space that was unusually empty. The galaxies that should have been there by statistical expectation were not there in the numbers anticipated. The void was real, it was large, and it seemed, at least, in part, to be responsible for the anomalous coolness of the cosmic microwave background in that direction. The paper that formally identified the Eridanus Supervoid and connected it to the cold spot was published in 2007 by a team of astronomers who had been carefully analyzing galaxy survey data. Their conclusion was careful and measured, as scientific conclusions tend to be. The void they identified was consistent with the cold spot. It was a plausible explanation, but it was not, they noted, a complete explanation. The void they found could account for some of the temperature deficit in the cold spot, but not all of it. There was still something left over, still something that the supervoid alone did not fully explain. That remainder, that leftover anomaly, has been a subject of active research and debate ever since. Some scientists have proposed that the void is even larger than initially measured, and that a more accurate account of its full extent would close the gap between prediction and observation. Others have suggested that additional physical effects beyond the standard integrated Sachs-Wolf mechanism might be at play, and some have proposed more exotic explanations, ideas that reach beyond the standard model of cosmology into territory that is, to put it plainly, speculative, but not uninteresting. We will visit that territory soon, but what I want you to feel right now is the particular quality of this discovery. The Eridanus Supervoid was not found by anyone looking for it directly. It was not the target of an expedition, the object of a focused search. It was found by following a question, by noticing an anomaly in one dataset, the cosmic microwave background, and then looking to another dataset, the galaxy surveys, to see if the anomaly had a physical cause. It was found through a process of inference, of connecting observations made with different instruments at different times for different original purposes, and finding that they pointed at the same strange, empty place. This is how science often works, not in the dramatic flash of sudden discovery, but in the slow, careful triangulation of different kinds of evidence, each one incomplete on its own, but together building toward something. The void was not seen directly. It was inferred. It was deduced from what was not there, from the silence in the galaxy distribution, from the cold in the ancient light. It was found because someone was paying attention to the blank spaces, to the places on the map where the expected was absent, to the cold where warmth was expected, the emptiness where abundance should have been. And in finding it, they opened a door into a region of the universe, unlike almost anything we know, a door into 1 billion light years of quiet, a door into a question that even now, years after its discovery, the best minds in cosmology have not fully answered. How can such a place exist? Why does the universe have a wound this large? The traveler, moving through the dark, carries this question with them. It is company of a kind, in a place that offers little other company. And we, following at a distance, carry it too. Why does the universe have a wound this large? Let that question settle into you as you breathe. Let it ask itself quietly. Without urgency, there is time. The void is patient. And the answer, when it comes, or when it almost comes, will be worth the waiting. There is a kind of cold that is not about temperature. You have felt it, perhaps, in certain moments. Standing in an old building, where something sad happened long ago. Walking through a forest at dusk when the light changes in a particular way. Reading a letter that carries news you were not prepared for. It is a cold that does not register on thermometers. It is a cold of meaning, of weight, of the sense that something is present that you cannot quite name. The cold spot in the cosmic microwave background has a little of that quality when you sit with it long enough. Let me explain what it is, and then let us feel it together. The cosmic microwave background is the oldest light in the universe. It was released approximately 380,000 years after the Big Bang, at the moment when the universe had cooled enough for electrons to combine with protons and form the first hydrogen atoms. Before that moment, the universe was a dense, hot plasma, opaque to light. Photons could not travel freely. They were constantly being scattered, absorbed, re-emitted. The universe was like a fog so thick that nothing could see through it. Then, at that 380,000-year mark, something changed. The universe crossed a threshold. The plasma became transparent. Light was suddenly free to travel. And the light that was released in that moment, that first free light, has been traveling ever since. For 13.8 billion years, it has been moving through the expanding universe, stretching as the universe stretches, cooling as the universe cools. Today it arrives at us from every direction in the sky, not as visible light, but as microwave radiation at a temperature of just under 3 degrees above absolute zero. When we map this light, we are looking at the universe as it was almost 14 billion years ago. We are seeing the earliest accessible moment in cosmic history, a portrait of the universe when it was less than 300,000 years old. The fluctuations in this map, the tiny temperature differences from one region to another, represent the slight variations in density that existed at that early time. Denser regions were a tiny bit warmer. Less dense regions were a tiny bit cooler. Most of those fluctuations are small, and they follow a particular statistical distribution that cosmologists can predict and model very precisely. The standard model of cosmology, the lambda CDM model, makes specific predictions about what this distribution should look like. And in almost every respect, the observations match the predictions with remarkable accuracy. This is one of the great triumphs of modern cosmology, that we can calculate what the universe looked like almost 14 billion years ago and find that our calculations are correct. But there are a few places where the match is imperfect, a few anomalies, where the observed map differs from what the models predict. And among these anomalies, the cold spot in the direction of Eridanus is one of the most persistent and most discussed. The cold spot is a region of the microwave sky, roughly 5 degrees across, in angular size, where the temperature is lower than expected, not lower than the average temperature of the cosmic microwave background, which is itself just barely above absolute zero, lower than expected given the statistical distribution that the standard model predicts. It is an outlier, a place where the ancient light is colder than it should be by a margin that is statistically significant. How significant? Estimates vary, but many analyses suggest that a cold spot this large and this cold would be expected to occur by chance only once in a very large number of simulations of the universe. Some analyses put the probability of it arising by chance at less than 1%. Others argue it is more common than that, depending on how exactly you define and measure it. The debate about its statistical significance is ongoing, but the feature itself is real. It is in the data. It does not go away when you look more carefully. It has been confirmed by multiple instruments and multiple analyses, including data from the European Space Agency's Planck satellite, which produced the most detailed map of the cosmic microwave background ever made. So we have an anomaly, an unexpected coldness in the oldest light we can see, and we have a supervoid, an enormous region of space in the same direction, containing far fewer galaxies than expected. Are these two things connected? The mechanism that connects them, the integrated Sachs-Wolf effect, is worth understanding because it is beautiful in its own quiet way. When a photon of light passes through a region of space, it is affected by the gravitational environment of that region. If it passes through a region that is denser than average, it falls into a gravitational well. In a static universe, it would gain energy falling in and lose the same amount climbing out, with no net effect. But we do not live in a static universe. We live in an expanding one, and in an expanding universe, by the time the photon has crossed the gravitational well and is climbing out the other side, the well has changed. It has become shallower because the universe has expanded. The photon climbs out of a shallower well than the one it fell into. It comes out with more energy than it went in with. It is slightly blue-shifted, slightly warmer. Now reverse the scenario. A photon passes through a void, a region less dense than average. Instead of falling into a gravitational well, it crosses a gravitational hill. It climbs over the hill and descends the other side. In a static universe, the energy gained going down would equal the energy lost going up. But in an expanding universe, by the time the photon has crossed the void, the hill has become lower. The photon descended from a lower point than the one it climbed to. It loses a little energy. It arrives at the observer slightly redshifted, slightly cooler. A very large void, like the Eridanus Supervoid, would imprint a cold signal on the cosmic microwave background by exactly this mechanism. Light crossing, the void would emerge slightly cooler than light that had not crossed the void. And the larger and emptier the void, the stronger this effect would be. When researchers measured the Eridanus Supervoid and calculated the cold imprint it should produce through the integrated Sachs-Wolf effect, they found that the void could account for part of the cold spot, but not all of it. The Void is large enough and empty enough to explain some of the temperature deficit, but even with the most generous estimates of its size and emptiness, there is still something left over. The cold spot is colder than the supervoid alone can explain. This is the part that makes the cold spot interesting, not just as an observational anomaly, but as a genuine scientific puzzle. If the supervoid fully explained the cold spot, the story would be relatively tidy. A large void, an expected physical effect, a measurable consequence. Unusual but not inexplicable, but the partial explanation leaves room for other things. 4. Additional physics that we have not accounted for effects that our models do not yet include, for possibilities that sit, depending on your perspective, somewhere between fascinating and unsettling. Some researchers have proposed that the cold spot, including its unexplained excess coldness, might be evidence of physics beyond the standard model of cosmology. Perhaps the properties of dark energy in that region of space are different from what we assume. Perhaps there are structures within or behind the void that contribute to the effect. Perhaps, in the most speculative corner of scientific thinking, the cold spot is a hint of something even stranger, something we will explore in later parts of this journey. But for now, I want to sit with the image itself. A cold spot in the oldest light in the universe, a patch of the ancient sky that is quieter, dimmer, less energetic than it should be, and behind it, stretching for 1 billion light years, a void that is emptier than almost anywhere else we know. There is a particular quality to coldness that we associate with certain emotional states, with loneliness, with absence, with the feeling of being in a place where warmth used to be and is no longer. The cold spot is not emotional. Of course, it is a physical measurement, a difference in temperature so small that no human sense could ever detect it. But the metaphor is hard to avoid. Something in the universe, in that direction, is colder than expected. Something in the universe, in that direction, is empty in a way that leaves a trace on the oldest light we can see. As our traveler moves through the void, they are moving through the thing. That makes that cold spot cold. They are inside the explanation. They are the interior of the anomaly, and the light that passes through above them and below them and in every direction around them. Ancient light on its long journey from the beginning of time is losing a little energy as it crosses, becoming just, slightly, unmeasurably, almost imperceptibly cooler. The void whispers to the ancient light, and the ancient light carries that whisper all the way to us, billions of years later, as a faint, unexplained coldness in the map of the beginning. Let that image carry you, the whisper of an empty place, written in the temperature of ancient light, still reaching us across billions of years, still telling us that something in a particular direction is quieter than it should be, still asking us, gently, patiently, to explain why. 200 million light years into the void, the traveler has been moving for what, in any human accounting of time, would be an incomprehensible duration. But time inside the void has a different texture than time outside it. Outside, in the galaxy-rich regions of the cosmic web, time is marked by events. A star ignites. A galaxy collides with its neighbor. A supernova blooms and fades. These are the punctuation marks of cosmic time, the moments that break the flow into something that can be measured and remembered. Inside the void, there are no punctuation marks. There is only the continuous, featureless sentence of the dark. The traveler has learned to count time differently, not by events, but by the slow, patient accumulation of distance, by the knowledge that each moment, however indistinguishable from the last, has carried them a little further, across the emptiness. This is a different relationship with time than most of us are used to. We are creatures of events. We mark our lives by the things that happen in them. But the void teaches something else. It teaches that time passes even when nothing happens. That distance accumulates even when there is nothing to mark it. That the journey continues even when the journey looks exactly the same as it did a moment ago, and 1,000 years ago, and a million years ago. The traveler looks behind them. The galaxies they left at the edge of the void are gone now. Not gone in the sense of having disappeared or moved. They are still there, still glowing with the light of their billions of stars. But they are so far away that their light has thinned to something below the threshold of detection. Even with instruments of extraordinary sensitivity, the boundary of the void is too remote to see. The traveler is surrounded in all directions by the same deep, dark. There is a particular quality to this moment that is worth sitting with. The moment when you can no longer see where you came from, and you cannot yet see where you are going. When both the origin and the destination are equally invisible, equally remote, equally unreachable. You are in the middle of something immense, with no reference point except the direction of your own motion and the certainty that you have been moving, and that moving is the right thing to do. Most of us have felt something like this in our lives, on a smaller scale. Moments in the middle of long journeys, literal or metaphorical, when the beginning is too far behind to see and the end is not yet in sight. Moments of transition, of change, of the particular uncertainty that comes from being fully committed to something whose outcome you cannot yet observe. Those moments can be frightening, but they can also be clarifying. They strip away everything except the essential. You are moving. The direction is chosen. Nothing remains but the moving itself. The void offers a cosmic version of this experience. The traveler does not panic. We said this before, and we say it again, because it is worth repeating. The void, for all its immensity, is not hostile. It is not trying to do anything to the traveler. It is simply there. It has no intention, no agenda, no relationship to the small moving thing crossing its interior. It is vast and neutral and patient in the way that only truly large things can be patient. And in that neutrality, there is a kind of peace, if you are willing to receive it as such rather than fighting against it. The traveler has been thinking in the long silences about what they expected the void to feel like before they entered it. They expected emptiness, of course, but they expected emptiness to feel like something, like deprivation. In the deepest emptiness, the universe still hums. There is something in that worth holding on to as you lie in your own quiet place tonight. Even in the most barren region of the observable universe, even in a space so empty that crossing it would take 1 billion years, the earliest light of everything still fills the air. The void is not cut off. It is not outside the universe. It is inside it, woven into the same fabric, bathed in the same ancient radiation. It is empty of galaxies, but it is not empty of the universe. And that is not nothing. That is, in fact, quite a lot. The traveler moves on. They have crossed 200 million light years of nothing, and they have 5 times that still ahead. The far edge of the void is still invisible, still impossibly remote. The near edge, where the galaxies begin again, is equally inaccessible behind them. They are in the deep middle of the emptiness, and the deep middle is its own kind of place. It has its own kind of beauty, the traveler decides. Not the beauty of the galaxy-rich regions, not the beauty of color and structure and the drama of stars being born and dying. A quieter beauty, the beauty of a room with nothing in it, where the architecture itself becomes the point. The beauty of a long pause in music, where the silence is not empty, but full of what came before and what will come after. The beauty of the negative space in a painting, the unpainted part that gives the painted part its form. The Eridanus Supervoid is the negative space of the universe in this region, and it is enormous, and it is real, and it has been here for almost as long as the universe itself. Something about this long emptiness begins to feel like rest, not the rest of sleep. Exactly, though sleep is where we are heading, but the rest of release, of letting go of the need for things to be happening, of accepting that a journey can be mostly crossing, mostly the space between departures and arrivals, and that the crossing itself is not wasted time. It is part of the journey. It is the journey. The traveler breathes in the way that travelers in their imagination breathe, slowly, deeply, adjusted to the long patience of the void. And the darkness around them is not threatening. It is simply there. It is the universe in its most minimal form. And minimal, the traveler is discovering, does not mean lesser. It means distilled, reduced to what remains when everything superfluous is absent. What remains in a void of 1 billion light years is space itself, and time, and the faint hum of ancient light, and the slow, patient crossing of something small through something enormous. And that, it turns out, is enough. Science is comfortable with large things. It has had to become comfortable with them over the centuries as each generation of instruments and theories has pushed the boundaries of what we can observe and understand. The size of the Earth, once thought to be the entirety of everything, turned out to be almost nothing compared to the solar system. The solar system turned out to be a speck within the galaxy. The galaxy turned out to be one among hundreds of billions. At each stage, what seemed impossibly large became merely large, and then merely average, and then small. We have a good track record of adjusting our sense of scale. But the Eridanus Supervoid presents a different kind of challenge. It is not simply large in the way that galaxies and superclusters are large. It is large in a way that strains the predictions of the very models we use to understand the universe. It is, in the language of cosmology, statistically anomalous. And in a universe governed by precise physical laws and well-understood initial conditions, statistically anomalous is another way of saying something here does not quite fit. To understand why, we need to think about how the universe builds its structure. It begins with the Big Bang. In the first moments, the universe is extraordinarily hot and dense, and matter is distributed nearly uniformly in every direction. Nearly, but not perfectly. There are tiny quantum fluctuations, random variations in density that exist because at the smallest scales, the universe is fundamentally probabilistic. These fluctuations are minuscule, but they are real, and in a universe governed by gravity, real differences in density, no matter how small, have consequences. As the universe expands and cools, gravity goes to work on these tiny fluctuations. Regions that are slightly denser than average attract more matter. The extra matter makes them denser still. They attract more. The process is self-reinforcing. Over hundreds of millions and then billions of years, these slight overdensities grow into the structures we observe today. Galaxies, clusters, superclusters, the great filaments and walls of the cosmic web. Meanwhile, the regions that were slightly less dense than average go the other way. Matter flows out of them toward the denser regions. They become less dense. Less dense, they attract even less. The process runs in reverse, draining them further over time. These are the voids, the hollow spaces in the cosmic foam. This picture is well understood. It is modeled with extraordinary precision in computer simulations that track the behavior of millions of particles, representing matter across cosmic scales. These simulations, run on some of the most powerful computers available, produce universes that look remarkably like the one we observe. They produce galaxies, clusters, filaments, walls, and voids. They produce a cosmic web whose statistics match the observed universe with impressive accuracy. And they produce voids, many voids of many sizes, small voids, tens of millions of light years across, larger voids, 100 million light years across. Occasionally, in the simulations, voids that approach 2 or 300 million light years. The distribution of void sizes follows a pattern, a statistical curve with many small voids and progressively fewer large ones. But voids of the size of the Eridanus Supervoid, approaching or exceeding 1 billion light years, are vanishingly rare in these simulations. Not impossible. Nothing in physics forbids them, but the probability of one occurring, given the standard initial conditions of the Big Bang and the standard laws of physics that govern cosmic evolution, is very small. Some analyses suggest that in a universe like ours, a void of this size should occur, by chance perhaps once in every 1,000 simulations, or perhaps even less frequently than that. We live in one universe, not 1,000. So the question becomes, are we simply the lucky residents of one of the rare universes that happens to contain such a void, or is something else going on? Is there a physical reason, something our models are missing, that makes the Eridanus Supervoid not just possible but actually likely? This is not merely a philosophical question. It is a scientific one with real implications for our understanding of the universe. If the void is simply a rare statistical outcome, then we note it, we study it, and we move on, acknowledging that rare events do sometimes occur. But if it is too rare, if the probability of it occurring by chance falls below a certain threshold, then it begins to suggest that our models are incomplete, that there is some physics we do not yet understand that is producing these extreme structures. The tension is real, and it has not been resolved. Some researchers argue that the Eridanus Supervoid is consistent with the standard model at the edges of its predictions, but not outside them. They point out that measuring the exact size and emptiness of the void is difficult, and that different methods give somewhat different answers. They suggest that the most conservative measurements of the void bring it within the range of what the standard model can accommodate uncomfortably at the far tail of its distribution, but still within it. Other researchers are less comfortable. They look at the void size and emptiness and the persistent anomaly of the cold spot, which the void alone cannot fully explain, and they feel that something is being asked of our theories that our theories are not quite able to give, that the void is a sign, not of a universe behaving within the limits of our models, but of a universe that has done something our models predicted it would almost certainly not do. There is a phrase that appears in some of the scientific literature on this topic, a phrase that, in the careful, measured language of academic cosmology, carries a certain weight. The phrase is in tension with the standard model of cosmology. It means that the observation does not comfortably fit within the framework of our best current theory. It means that something needs to give, either the observation, which might be revised as measurements improve, or the theory, which might need to be extended or modified to accommodate the observation. The Eridanus Supervoid has been described as being in tension with the standard model, and the cold spot that accompanies it, the excess coldness that the void cannot fully account for, increases that tension. Together, they constitute a challenge, not a refutation, not a crisis, but a genuine challenge to the idea that we fully understand how the universe builds its largest structures. What might be missing from our models? Several possibilities have been proposed. One involves dark energy, the mysterious force that is causing the expansion of the universe to accelerate. Dark energy is included in the standard model, but its properties are assumed to be constant and uniform everywhere. What if they are not? What if dark energy behaves differently in different regions of space? A region where dark energy was slightly stronger than average might expand faster than surrounding regions, carving out a larger and deeper void than standard physics would predict. This is speculative. There is no direct evidence that dark energy varies in space. But the supervoid is the kind of observation that makes such speculation worth taking seriously. Another possibility involves the physics of the very early universe. Inflation, the period of extremely rapid expansion that preceded and shaped the Big Bang's aftermath, is thought to have smoothed out many of the irregularities that would otherwise have existed in the initial conditions. But inflation models themselves have parameters, values that are not determined by the theory itself but must be inferred from observation. If some of those parameters were slightly different from what we assume, the fluctuations that inflation imprinted on the universe might have a different character, one that more naturally produces extreme structures like the Eridanus Supervoid. A third possibility is more exotic, and we will visit it at length later in our journey. It involves the idea that the void might be the signature of a collision between our universe and another, a collision that left a bruise, an imprint, a wound, in the fabric of space that we are now observing as an anomalously empty and anomalously cold region. For now, the point is this: the Eridanus Supervoid is too large to be easily explained. It sits at the edge of what our best theories predict is possible, and perhaps beyond that edge. It asks something of our understanding of the universe that our understanding is not yet fully able to give. And that is, in the deepest sense, what makes it scientifically important. Not just as a curiosity, not just as a record setter in the category of large empty spaces, but as a question, a genuine, open, unresolved question, a place where the universe is telling us something that we have not yet fully learned to hear. Our traveler, crossing the interior of that question, does not have the answer, neither do we. And there is a particular kind of humility in that, worth sitting with in the quiet of this night. The universe contains things that our best minds, with their best tools and their best theories, cannot yet explain. And rather than being frightening, that is, in its own way, a comfort. It means the universe is still larger than our understanding of it. It means there is still more to learn. It means the map still has blank spaces, and those blank spaces are still inviting someone to look more carefully, to ask better questions, to find the explanations that are waiting just beyond the current edge of knowledge. The void is too big to explain easily, and that, perhaps, is exactly the right size for a mystery. The universe is not standing still. This is one of the most important things we know about it, and also one of the most counterintuitive. When we look at the night sky, it seems static. The stars are where they were last night, and where they will be tomorrow night. The constellations look the same as they did to people thousands of years ago. The universe, from our vantage point, gives the impression of a vast and fixed stage on which things happen, but which itself does not change. But this impression is wrong. The universe is expanding. Every part of it, every region of space, is moving away from every other region. The galaxies are not flying apart through space the way debris flies from an explosion. Rather, the space between them is growing. New space is being created, or rather the existing space is stretching in the way that dots drawn on a balloon move apart from each other as the balloon is inflated. The galaxies are not moving through space. The space itself is moving, stretching, expanding. This was discovered in the 1920s when Edwin Hubble observed that the light from distant galaxies was systematically redshifted, shifted toward the red end of the spectrum in a way that indicated they were receding. And the further away a galaxy was, the faster it appeared to be receding. This relationship, known as Hubble's law, was the first evidence that the universe is expanding. But there was more. In the late 1990s, two independent teams of astronomers, studying distant supernovae to measure the rate of the universe's expansion, made a discovery that surprised nearly everyone. The expansion of the universe is not slowing down, it is speeding up. The universe is not just expanding, it is expanding at an accelerating rate. Whatever was expected to break the expansion, whatever gravity was supposed to do to eventually slow and perhaps reverse it, was not working. Something was pushing the expansion faster and faster. That something was given the name dark energy. It is not dark in the sense of being sinister, only in the sense of being invisible and unknown. It is a property of space itself, an energy that resides in the vacuum that does not dilute as the universe expands but remains constant at every point, and that acts as a kind of repulsive force, counteracting gravity on the largest scales and driving the universe to accelerate its expansion. Dark energy, in the standard model of cosmology, accounts for approximately 68% of the total energy content of the universe. It is the dominant component of everything that exists, and we do not know what it is. We know it is there because the universe is accelerating. We know roughly how strong it is because we can measure the acceleration. But it's fundamental. Nature, what it is made of, why it has the value it has, what it means for the ultimate fate of the universe, remains deeply unknown. And it has a profound relationship with voids. Because voids are the regions of the universe where gravity is weakest, where the density of matter is lowest, where the attractive force that pulls matter together and counteracts dark energy is most diminished. And in those regions, dark energy has the most influence. It dominates. It drives the expansion more effectively where there is the least matter to resist it. The consequence is that voids grow. As the universe expands, matter continues to flow out of underdense regions into denser ones. The voids become emptier, and as they become emptier, dark energy's relative influence within them increases. The expansion accelerates inside them more than it does outside. The voids expand faster than the universe as a whole. They grow larger, deeper, more extreme over time. The Eridanus Supervoid is not the size it was a billion years ago. It was smaller then, less empty, its boundaries closer to what surrounded it. Over the billions of years since it formed, dark energy has been at work, driving the expansion of space within its boundaries at a rate slightly faster than the cosmic average, draining matter from its interior, pushing its edges further out into the surrounding regions. The void has been growing. It is larger today than it was when the ancient light we observe as the cold spot was passing through it, and it will continue to grow. In the far future, assuming the current understanding of dark energy is correct, the Eridanus Supervoid will be larger still. The galaxies at its edges will be pushed further away from each other. The few galaxies that exist within it will drift further apart. The void will deepen, become emptier, expand into a region of space even more extreme than it is today. In the very long term future, in timescales that dwarf even the current age of the universe, the void's growth will contribute to what some cosmologists call the heat death of the universe, the final state in which matter is so dispersed and space is so vast that no new structures can form and no energy gradients remain to drive any processes. The void, in this sense, is a preview, a glimpse of the universe's eventual fate, writ small, or rather writ large, in a region where that fate has already been arriving gradually for billions of years. This connection between the Eridanus Supervoid and dark energy is one of the reasons scientists find it so valuable. Voids are natural laboratories for studying dark energy because they are the places where dark energy's effects are least masked by the competing influence of matter. By studying how voids grow and evolve, by comparing observations of their current state with predictions from models with different dark energy properties, astronomers can probe the nature of dark energy with a precision that is difficult to achieve by other means. The Eridanus Supervoid, being one of the largest voids known, is one of the most powerful such laboratories available. If its size and emptiness can be measured precisely, and if those measurements can be compared with detailed simulations of how different dark energy models produce voids, the comparison may reveal something about the nature of dark energy that we do not yet know. Whether it is truly constant, as the simplest version of the standard model assumes, whether it varies in space or time, whether it is a single uniform field or something more complex. The void may be, in a very real sense, a measuring instrument for one of the most fundamental and most mysterious forces in the universe. But there is another dimension to this story, a more personal one, if personal can mean anything when we are talking about something this large. The fact that the Eridanus Supervoid is growing, that it is expanding under the influence of dark energy, means that it is dynamic. It is not a static feature of the universe. It is changing, slowly, almost imperceptibly slowly by any human standard of time, but changing. The traveler crossing it today is crossing something that is not quite the same as what an earlier traveler would have crossed. The void is slightly larger, slightly emptier, the galaxies at its edges slightly further away, and a traveler who crossed it in the distant future would find it larger still, deeper still, quieter still. The desert is growing. There is something melancholy in that, if you let yourself feel it. The universe, in some regions, is becoming more empty rather than less. The structures that galaxies represent, the collections of matter and light and chemistry and, perhaps, life, are becoming more isolated from each other. The great web is growing less dense in its voids, pulling matter away into the filaments and clusters, concentrating it there while leaving the deserts more desolate. But melancholy is not the only response available. There is also wonder. To know that we live in a universe where space itself is a dynamic thing, where emptiness grows and contracts, where the fabric of reality is not fixed but evolving, expanding, driven by a mysterious energy that fills every corner of existence, is extraordinary. It is one of the most remarkable facts that science has ever produced. And the Eridanus Supervoid, in its enormous, growing, dark energy-driven emptiness, is one of the places where that fact is most visible. The traveler, moving through the void, is moving through a space that is not merely empty, but actively becoming more empty. The region around them is not standing still. It is expanding, gently, imperceptibly, driven by the same dark energy that is stretching the universe in every direction. They are inside the expansion. They are inside the process. And we, here in our quiet rooms, breathing slowly in the dark, are inside it too. The universe is expanding around us right now, in this moment, as you listen. The galaxies are receding. The space between them is growing. Dark energy is doing its patient work in every corner of existence, including this one. We are, all of us, travelers inside the expansion. And the void, in its growing silence, is simply the place where the expansion is most clearly, most starkly, most beautifully visible. Somewhere deep inside the Eridanus Supervoid, there is a point that is equidistant from both edges. A midpoint, the center of the emptiness. The place where, if you looked in any direction, the distance to the nearest galaxy-rich region would be approximately the same. 500 million light-years to one side, 500 million light-years to the other, 500 million light-years above and below, and in every compass direction that the three-dimensional geometry of the void allows. The traveler reaches this point. They stop, not because stopping is required, not because the void demands it, but because the midpoint seems to deserve a pause, a moment of acknowledgement. You do not cross the center of the largest emptiness in the known universe without stopping to notice that you have done so. The traveler turns slowly, looking in each direction. The view is the same in all of them: dark, quiet, empty. There is a particular philosophical weight to the midpoint of anything. The middle of a journey is the place that is furthest from both beginning and end, furthest from the safety of departure and the relief of arrival. It is the point of maximum commitment. You have come too far to turn back without as much effort as going forward. The only rational choice, if rationality applies to anything in a billion light-year void, is to continue. But more than that, the midpoint is the place where the journey becomes most fully itself. At the beginning, you are still close enough to the origin to feel it at your back, still near enough to the familiar to use it as a reference. At the end, you are already arriving, already beginning to re-enter the known. But at the midpoint, you are the journey. Nothing else is present. Only the crossing, only the emptiness, only the self moving through the dark. The traveler sits with this. They think about what it means to be here, at this specific point in space, at this specific moment in time. The void around them has been empty, in the way it is empty now, for billions of years. Long before any planet in any galaxy formed. Long before any life arose to wonder at the universe. Long before any civilization built its first telescope or wrote its first equation or looked up at the night sky and asked, for the first time, what is out there? This emptiness has been here, patient, unchanged, waiting. If waiting is a word that can apply to something with no awareness, no intention, no sense of time. And now something has arrived. Something small, something finite, something temporary. A traveler crossing the void on a journey that is, by the standards of the void, almost instantaneous. A consciousness moving through a space that has never contained consciousness before, noticing it for the first time. There is something almost sacred about this, the traveler thinks. Not in any religious sense, not necessarily, but sacred in the older, more essential sense of the word. Marked, set apart, worthy of a kind of attention that ordinary moments do not always receive. The universe, in this place, has been alone for billions of years. And for this brief moment, it is not alone. Something is here. Something is paying attention. The traveler stays for what is, in the context of their journey, a very long time. Long enough that the void begins to feel less alien. Long enough that the emptiness begins to have texture. The way a very quiet room eventually reveals the sounds that were always there, but too subtle to notice at first. The faint background radiation. The quantum fluctuations that are the universe's most basic language. The way matter and energy whisper to each other at scales far smaller than atoms. The slow, patient expansion of space itself. The void is not nothing. We have said this before, but here at the midpoint it feels most true. The void is space and time and the ancient light of creation and the quantum substrate of reality. It is just very, very few galaxies. It is the universe in its most minimal expression. And that minimalism, the traveler is finding, has its own kind of presence. You have to become very still to feel it, very quiet. You have to let go of the expectation of something more, the habit of looking for structure and finding reassurance in it. You have to be willing to rest in the absence of that reassurance, to discover that you are okay without it, that the self does not require the stimulation of the rich and complicated universe to remain intact. The self can be here, in the emptiness, and still be a self. This is not a lesson that the void is trying to teach. The void has no curriculum, no intention, no relationship to the traveler or to us. But it is a lesson that can be taken from the experience of being here. That presence does not require fullness, that the self does not dissolve in emptiness. That quiet is not the same as absent. The traveler thinks about the people or the beings or the awareness of whatever kind that might exist on a planet somewhere in one of the rare galaxies of this void. They would have grown up in this emptiness. The darkness around their world would be the only darkness they knew. They would not have the context that our traveler has, the knowledge of what lies outside. They would not experience the void as emptiness, because they would have no experience of fullness to compare it to. For them, this would simply be the universe. This would be normal. And perhaps, the traveler thinks, from their perspective, the galaxy-rich regions of the cosmic web, the crowded clusters and the bright filaments would seem the strange ones. Too full, too busy, too noisy. They might look at images of dense galaxy clusters and find them overwhelming, and wonder how anything could be that crammed with light and matter and activity. They might prefer, if preference is meaningful at such scales, the clean and patient emptiness of their own familiar dark. This is the most intimate thing about the midpoint of the void. It reminds you that normal is always relative, that what feels like emptiness from one perspective is simply existence from another, that the universe is not organized around any particular sense of what is appropriate or expected or comfortable. It simply is. And every place in it, every condition, every degree of density or sparseness is equally real, equally part of the whole. The traveler begins to move again. Forward, always forward. The far edge of the void is still 500 million light years away. The journey is only half done, but the midpoint has given something, some quality of attention or acceptance or simple presence, that will travel with them the rest of the way. They carry the midpoint inside them as they move. And we, in our quiet rooms, carry something of it too. The reminder that we are also, in our own way, at a midpoint, between the beginning of things and their end, between the birth of whatever we are becoming and the completion of whatever that is, moving through time the way the traveler moves through the void, with the past receding behind us and the future still invisible ahead. And the emptiness around us, the quiet, the dark of this night, is not a lack. It is a space in which something small and finite and aware is moving, noticing, being. That is enough. That is, in the middle of a billion light-year void, and in the middle of a night that is already beginning to deepen towards sleep, more than enough. Every civilization that has ever looked at the sky has eventually asked the same question, not always in the same words, not always with the same framework or the same tools. But the question itself, in its most essential form, is universal. What happened here? Why does this place look different from the rest? What force, what event, what process left this particular mark on the face of things? We ask it of scars on our own bodies. We ask it of ruins in ancient cities. We ask it of craters on the moon and rings on trees and fault lines in the earth. We are, at our core, a species that looks at marks and tries to read them, that interprets difference as the record of something that occurred, that treats the unusual not as arbitrary but as meaningful, as the aftermath of a story we have not yet fully heard. The Eridanus Supervoid is unusual. We have established that. And so, inevitably, the question arises, what happened here? What made this place so empty when the rest of the universe, in every direction, is so much fuller? What process, what event, what wound left this billion light-year hole in the fabric of the cosmic web? The standard answer, the answer that mainstream cosmology currently offers, is that nothing dramatic happened. The void is the product of ordinary cosmic processes, the same gravitational dynamics that produce all voids everywhere, simply taken to an extreme. An initially underdense region grew emptier over billions of years as matter drained away into surrounding structures. The cold spot in the cosmic microwave background is, partly, the signature of this process, light losing energy as it crosses the shallow gravitational landscape of the void. There was no wound. There was only the quiet, patient work of gravity and expansion, doing what they always do, just more so. But mainstream cosmology, for all its power and precision, does not fully explain the cold spot. The void is too large, the coldness somewhat too deep. And where an explanation is incomplete, speculation is not merely permitted but necessary. Science advances not only through the confirmation of what we expect, but through the honest acknowledgement of what we cannot yet explain, and through the willingness to propose ideas that might be wrong, that might be strange, that might require entirely new ways of thinking about the universe. One of those ideas is that the Eridanus Supervoid is, in some sense, a wound. Not a wound in the metaphorical sense of something that hurts, not a wound in the emotional sense of damage done to something that feels, but a wound in the structural sense, a disruption in the fabric of space, a place where the universe's usual continuity has been interrupted or altered by some process more dramatic than the ordinary flow of cosmic evolution. One framework for thinking about this involves what physicists call topological defects. In the very early universe, during and immediately after inflation, the universe underwent phase transitions, changes in state not unlike the freezing of water into ice or the cooling of a magnet below its critical temperature. When such transitions happen throughout a large volume simultaneously, they do not always proceed uniformly. Different regions can settle into different states, and the boundaries between those regions can become locked in as permanent structural features of space. Lines of concentrated energy called cosmic strings, surfaces called domain walls, points of extreme density called monopoles. These topological defects, if they exist, are not just abstract theoretical curiosities. They would be real physical structures, encoded into the geometry of space itself, relics of the phase transitions of the early universe. And they might, under some models, influence the distribution of matter and energy in ways that could contribute to large-scale anomalies in the cosmic web. Could a topological defect of some kind be associated with the Eridanus Supervoid? Could the void mark the location or the influence of a cosmic string, a domain wall, some structural feature of space that we have not yet directly detected? The idea is speculative. There is no confirmed evidence of topological defects in the universe, and the connection between such defects and the particular shape and scale of the supervoid is not well established theoretically. But the idea is not dismissed. It sits in the literature as a possibility, one of several unconventional explanations that researchers have considered when the conventional one proves insufficient. Another framework for thinking about the void as a wound involves a more fundamental kind of physics. General relativity, Einstein's theory of gravity, describes space-time as a dynamic entity, something that can curve, stretch, and distort in response to the presence of matter and energy. In the extreme conditions of the early universe, space-time was subjected to stresses and changes that we can barely imagine. And some physicists have wondered whether those stresses might have left permanent marks, regions where the geometry of space-time is subtly different from its average, regions where the rules of cosmic structure formation play out slightly differently than they do elsewhere. This is a speculative idea. Mainstream cosmology does not predict such permanent geometric wounds. But the supervoid is the kind of observation that makes people willing to consider ideas they might otherwise leave aside. When the standard model cannot quite explain what you observe, you look further. You ask stranger questions. You are willing, for a moment, to entertain the possibility that the universe has a history more complicated than your best current theory describes. There is also a purely aesthetic dimension to the wound idea, one that says something about how we as humans relate to large and unexplained things. We are drawn to the language of wounds because it implies a before and an after, a state of wholeness, a disruption, a changed state that persists. It implies a story. The universe was a certain way, something happened, and now there is this mark. And the mark is a record of the thing that happened, a way of reading backward from the present into the past, of recovering the story from its aftermath. The void, seen as a wound, becomes narrative. It becomes a place with a history, not just a statistical outcome of impersonal processes, but the result of something, an event, a moment in the universe's past that was different enough from what came before and after that it left a permanent impression. Whether or not this is literally true, whether the void is the result of some dramatic early universe event or simply the extreme tale of a statistical distribution, the wound metaphor captures something real about how it feels to contemplate the supervoid. It feels like something happened there. It feels like a place that is not simply empty, but deliberately emptied, as though matter and light and structure were pulled away from it or never allowed to gather there in the first place. Of course, feelings are not data. The void does not feel any particular way. It is a physical feature of the universe, governed by physical laws, and our emotional responses to it say more about us than about it. But our emotional responses are not therefore worthless. They are often the first signal that something is interesting, that a question is worth pursuing, that an anomaly deserves attention. The feeling that the void is a wound is the feeling that something here needs explaining, that the standard answer is not quite sufficient, that there is a story in this emptiness that we have not yet fully read. And that feeling, whatever its ultimate justification, is pointing us toward the right questions. Is the Eridanus Supervoid a cosmic wound? We do not know. We do not have the evidence to say yes, and we do not have the understanding to say confidently no. What we have is a place in the universe that is too empty, and a coldness in the ancient light that is too cold, and a question that sits in the middle of both of them, patient and unresolved. The traveler moves through the wound, if wound it is. They cannot see the marks of whatever made it. They cannot feel any difference between this space and any other. The void does not announce its own strangeness. It simply is. And in simply being, it asks, what happened here? What made this place? What story is written in this emptiness, waiting for a mind patient enough and curious enough and humble enough to learn how to read it? We do not have the answer tonight, but the question, asked quietly in the dark, is its own kind of company. There are ideas in science that begin as mathematics and end as philosophy. They start in equations, in the careful logical structures that physicists build to describe how the universe behaves. They are derived rigorously, tested against data, refined through debate. And then, at some point, they reach beyond what any experiment can currently verify. They reach into a territory where the tools of observation cannot yet follow, where the question is no longer simply what is the universe doing, but what kind of universe is the universe? Where physics becomes, if only at its edges, something closer to metaphysics. The idea of the multiverse is one of these. It is not fringe thinking. It emerges naturally from some of the most successful theoretical frameworks in modern physics. From string theory, which in its landscape of possible solutions seems to require an enormous number of different universes, each with different physical constants and properties. From eternal inflation, the idea that the inflationary expansion that shaped our early universe never truly stopped everywhere, but continues to this day in regions beyond our observable horizon, creating new bubble universes constantly. each one a separate cosmos with its own laws and its own history. From quantum mechanics, in whose many worlds interpretation, every quantum event that can go multiple ways does go multiple ways, branching the universe into an ever-growing tree of parallel realities. These are different versions of the multiverse idea. They do not all agree with each other, and none of them is currently supported by direct observational evidence. They are theoretical proposals, derived from our best current theories, that make predictions which may or may not be testable with future instruments and methods. But one prediction that some versions of the multiverse make is particularly relevant to our story. If our universe is one bubble in a vast sea of bubble universes, and if that sea is old enough and large enough, then collisions between bubbles are possible. Not collisions in the ordinary sense of solid objects impacting each other, but a more subtle kind of meeting, a touching of the boundaries of two expanding bubble universes, an interaction between their geometries and their physical properties that could, in principle, leave a mark, a bruise. A region of our universe where the geometry of space, the density of matter, the temperature of the cosmic microwave background were all slightly altered by the contact with another cosmos. And that bruise, some physicists have proposed, might look something like the cold spot in the direction of Eridanus. The idea was developed formally by several cosmologists in the years following the discovery and analysis of the cold spot. The argument is roughly this: if our universe, early in its history, brushed against or collided with another bubble universe, the region of contact would have been disturbed. Matter would have been redistributed. The cosmic microwave background in that region would show a temperature anomaly, and the distribution of galaxies in that direction, seen billions of years later, might show an anomalous underdensity, a void, where the collision disrupted the normal processes of structure formation. The Eridanus Supervoid and the cold spot, in this picture, are not two separate puzzles requiring two separate explanations. They are one thing. They are the aftermath of a collision between universes. They are the place where our cosmos was touched by another cosmos, and where that touch left a permanent, if subtle, mark. Is this true? We genuinely do not know. The bubble collision hypothesis is, at present, speculative. It makes predictions about the specific pattern of the temperature anomaly in the cosmic microwave background, predictions that differ in detail from what ordinary supervoid models predict. Some analyses of the Planck satellite data have looked for these predicted patterns and found hints that are, depending on who you ask, either suggestive or inconclusive. The data is complex, the statistical questions are subtle, and reasonable scientists disagree about what the evidence supports. What is not in dispute is that the idea is scientifically serious. It is not the province of pseudoscience or wishful thinking. It is a genuine theoretical proposal derived from well-motivated frameworks, making testable predictions, subject to the normal processes of scientific scrutiny and debate. It sits at the frontier of what is currently knowable, which is exactly where the most interesting science tends to live. But let us step back from the technical details for a moment and feel the full weight of what is being proposed. If the bubble collision hypothesis is correct, then the Eridanus Supervoid is not simply an empty region of our universe. It is a place where two universes met, where the boundary of everything we know touched the boundary of another everything, another cosmos with its own galaxies and stars, and perhaps its own forms of complexity. A place where, for a moment in the ancient history of our universe, we were adjacent to something else, something outside, something other. The void, in this picture, is not a wound in the sense of a damage to our universe alone. It is a meeting place, a threshold, the scar of a contact between realities that are otherwise forever separated, forever outside each other's light cones, forever inaccessible to any communication or observation. Two universes touched, once, in that early moment. And the touching left this, a billion light years of altered space, a cold whisper in the ancient light, a supervoid that our models cannot quite explain. There is something almost mythological about this picture. Almost every culture that has ever existed has some version of the idea of adjacent worlds, realms that border our own, that occasionally touch or intersect, that are separated by some boundary that is almost but not quite impermeable. The land of the dead and the land of the living, the spirit world and the physical world, the realm of the gods and the realm of mortals, the fairy realm and the human realm. Different names, different frameworks, different cultural meanings, but the same essential shape. There is here, and there is elsewhere, and they are not entirely separate. Physics, arriving at the multiverse through the rigorous path of mathematics, is proposing something structurally similar. Not the same, not with the same meaning or the same implications, but the same shape. Here and elsewhere, our universe and others, a boundary between them that is almost but not quite impermeable, and the Eridanus Supervoid as the place where that boundary was, briefly, not quite. Our traveler, floating in the middle of the void, thinks about this. They try to feel whether there is anything different about this space, whether the geometry of reality here carries any trace of that ancient contact, whether the quantum fields that permeate every corner of the universe are subtly different here, twisted by the touch of another cosmos. They cannot feel anything. The void is the void. It offers no direct sensation of its possible strangeness. But the traveler knows that absence of sensation is not absence of reality. The most important things in the universe are mostly undetectable to ordinary perception. Dark matter, dark energy, quantum fields, the curvature of space-time. They are all there, all real, all shaping the universe around us, all perfectly invisible to any of our senses. The void might be a door, even if it does not feel like one. It might be the place where our universe is closest to its outside, even if outside has no meaning in ordinary geometry. It might carry, in the pattern of its emptiness and its coldness, the signature of a contact that happened before any star existed, before any galaxy formed, in the first moments of everything. And we will never know for certain. Not yet, perhaps not ever, depending on how the science develops and what future instruments and theories can and cannot reveal. The multiverse, by definition, is outside our observable universe. We can only see its effects, if it has any, in the marks it leaves on what we can observe. The cold spot, the supervoid, the persistent anomaly that our best models cannot quite explain. Perhaps the explanation is mundane. Perhaps, as science progresses, someone will find a way to account for the cold spot and the supervoid within the standard model, and the mystery will dissolve into something interesting but not extraordinary. That is always possible. Science is full of apparent mysteries that turned out to have ordinary explanations. But perhaps not. Perhaps the void is a door. Perhaps the coldness in the ancient light is a whisper from outside. Perhaps the emptiness of a billion light years is the shape of a contact between everything we know and everything we will never know. Let that possibility rest in you as you breathe, as the night deepens and your thoughts grow softer and less insistent. You do not need to decide. You do not need to know. You only need to sit for a moment with the extraordinary fact that the question is genuinely open, that we live in a universe where that is a real scientific question, seriously considered by serious people with serious tools. The void is either a statistical outlier or a cosmic wound, or a multiverse door. And tonight, we do not know which. And the not knowing is, in its own strange way, one of the most beautiful things about it. It happens without announcement. The traveler has been moving through the void for what their instruments tell them is several 100 million light years. The darkness has been constant. The silence, In whatever sense silence applies to a place that was never capable of sound, has been unbroken. The void has offered nothing new, nothing different, nothing to mark the passage of time except the slow accumulation of distance on their instruments. And then, at the very edge of their detection systems, a signal. Not a strong signal, not the kind of signal that demands attention, that blazes across a detector and triggers alerts and changes the mood of a room. A faint signal, a whisper at the outermost limit of sensitivity. The kind of thing that could easily be noise, easily be an artifact, easily be the instruments deceiving themselves or the traveler deceiving their own hopes. But the traveler looks again, and the signal is still there. Light, very faint, very distant, very much at the edge of what can be detected. But light, and light, in a void of 1 billion light years, is not nothing. Light, in a place this empty, is everything. The traveler adjusts their course slightly, orienting toward the source. And as they move closer, over what will prove to be a journey of many millions of light years more, the signal strengthens. Slowly, gradually, the way an idea clarifies when you stop trying to force it and simply wait for it. The faint smudge of light resolves across the enormous patience of the journey into something identifiable. A galaxy, small, dimmer than average, a modest spiral, its arms not as grand or as sweeping as the Milky Way's, its stellar population thinner, its star formation proceeding at a slow and gentle pace, like a fire that is not going out but is not rushing either. A quiet galaxy, a solitary one. The traveler approaches as closely as they can and looks. The galaxy hangs in the void the way a single lantern hangs in a very large and very dark room. It is surrounded on all sides by the same emptiness that the traveler has been crossing for hundreds of millions of light years. There are no neighbors visible, no companion galaxies nearby, no cluster, no filament of other galaxies connecting it to the rest of the cosmic web. It is alone in a way that even the word alone does not quite capture, because alone usually implies the possibility of others nearby, others out of sight, but not out of reach. This galaxy is alone in a way that means the nearest other galaxy is likely tens or hundreds of millions of light years away. And yet it is here. It exists. It has been here, quietly turning, quietly forming stars and hosting planetary systems and doing all the slow, patient things that galaxies do for billions of years. In the middle of the void, in the middle of the nothing, a something, the traveler stays for a while, looking at it. They think about what it would be like to live there, to be born on a planet orbiting one of this galaxy's stars, to grow up under a sky that is darker than most skies in the universe. Not dark in the sense of being unlit. The stars of your own galaxy would still fill the sky with their cold fire. But the deep sky, the sky beyond your galaxy, would be far emptier than ours. Where we see thousands of other galaxies in a long exposure photograph of the night sky, the inhabitants of this galaxy might see almost none. One or two, perhaps, if they looked in exactly the right direction with exactly the right instruments. Faint and barely distinguishable from the background. The universe would feel very small to them, in one sense. Very contained. Very much limited to the island of their own galaxy and the bare, dark ocean stretching in every direction beyond it. But would they know? Would they feel the void around them as emptiness, as an absence of something that should be there? Perhaps not. Perhaps, if you have grown up in the void is simply the universe. The sky is dark beyond your galaxy because the sky is always dark beyond your galaxy. You have no memory of a fuller sky, no expectation of neighbors, no sense of having been placed in an unusual or extreme location. The void is the background against which all your experience of existence is set, and so you do not experience it as a void. You experience it simply as the universe. This is one of the deepest lessons that the void has to offer. The relativity not just of motion or of time, but of normal. What is normal is always what you're used to. And what you are used to is determined entirely by where you find yourself in the vast and varied geography of the universe. We, here in our galaxy-rich corner of the cosmic web, experience the universe as full of other galaxies, full of light reaching us from billions of years away, full of the evidence that we are not alone in our island, but surrounded by billions of other islands, each one bright with the fire of its billions of stars. That fullness shapes everything. It shapes our science, our philosophy, our sense of cosmic belonging. The inhabitants of the void galaxy have none of that, or very little. Their universe is quieter, darker, more solitary. Their science, if they have science, might have taken much longer to discover that other galaxies exist at all. Their philosophy might be organized around different questions of solitude and meaning in a universe that offers less visible evidence of abundance. And yet the physical laws governing their world would be identical to ours. The same atoms, the same forces, the same quantum fields, the same thermodynamics. The same chemistry that makes carbon useful and water extraordinary and the conditions for life what they are. The same stars, burning by the same nuclear processes. The same deep structure of reality. Only the neighborhood is different. Only the view from the window. The traveler looks at the lone galaxy for a long time. They think about all the suns that must be inside it, all the planets orbiting those suns, all the possible complexity that billions of years and the right chemistry can produce. They wonder, as they have wondered before, but never quite this acutely, whether there is anyone in there looking back, whether there is any awareness, anywhere in that faint spiral of light, that is itself wondering about the dark. There is no way to know. There is no signal, no indication, no evidence either way. The galaxy holds its secrets, as all galaxies do, behind distances that make communication effectively impossible and personal verification entirely out of reach. The traveler can see the light. They cannot know what the light comes from, in the deepest sense, cannot know whether it is only physics, only stars and gas and dust doing what physics requires, or whether somewhere in the intricate chemistry of some small warm world, something has arisen that feels the vastness around it and is moved by that feeling. They hope, the traveler does, in the quiet and personal way that hoping happens when no one is listening. They hope there is someone there. They hope the galaxy is not entirely alone in the way that a place without awareness is alone. They hope the void has been noticed from the inside as well as from the outside. That whatever lives in that faint spiral has looked out into the dark and felt the immensity of it and been, in whatever way awareness allows, changed by that feeling. Because to look at something vast and be changed by it is the most human thing there is, perhaps the most alive thing there is. And the thought that life might do that even in the deepest void, even in the most solitary galaxy in the most empty region of the universe, is among the most comforting thoughts the traveler has had on this long crossing. They move on, eventually. The galaxy recedes behind them. Its light fades back toward the threshold of detection and then below it, back into the dark from which it briefly emerged. The void closes around the traveler again, as patient and as deep as before. But something has shifted. The crossing is no longer entirely featureless. There was a galaxy. There was light. There was the possibility, however unverifiable, of something inside that light that was aware. And that possibility, that small and unconfirmable hope, is enough to carry forward into the remaining emptiness. The void is almost empty, but almost is not entirely. And in the space between almost and entirely, a great deal can live. Loneliness is usually thought of as a human problem, a condition that arises from the particular social nature of our species, from the fact that we are wired for connection, that we need each other in ways that go beyond the practical, that the absence of belonging produces in us something that functions almost like pain. We have a word for it. We have therapies for it. We have entire traditions of art and literature devoted to exploring it, because it is a fundamental part of the human experience. It is not a flaw in our design. It is a feature. We are built to feel the absence of others, because we are built to need them. But the Eridanus Supervoid invites us to think about loneliness differently, to think about it not as a uniquely human condition, but as a cosmic one, to see that at the largest scales of the universe, something structurally similar to loneliness is built into the architecture of space itself. Not loneliness in the sense of feeling. The universe does not feel. Galaxies do not experience their isolation. The void does not suffer its emptiness. We are careful not to project consciousness onto things that do not have it, because doing so is not only scientifically imprecise, but also, in its own way, a failure of respect for both the cosmos and for the genuine mystery of consciousness. But loneliness in the structural sense, in the sense of being separated from others of your kind by distances that make contact effectively impossible, in the sense of existing in a neighborhood where the nearest neighbor is so far away that no signal, no light, no influence of any kind could meaningfully connect you across the time available. In that structural sense, the galaxies of the Eridanus Supervoid are, in fact, lonely, profoundly, cosmically, definitively so. And there is something worth sitting with in that fact. Consider what it means for a galaxy to be isolated in the void, not just distant from others, as all galaxies are distant from each other, distant in the particular way of the void, where the nearest neighbor might be hundreds of millions of light years away. In ordinary cosmic neighborhoods, galaxies interact. They tug on each other gravitationally, distorting each other's shapes and altering each other's evolutionary trajectories. They occasionally collide and merge, catastrophically reorganizing their stars into new configurations. They exchange gas, sometimes stripping each other of the raw material for star formation, sometimes donating it. They are members of groups and clusters, embedded in a social structure of a kind, a gravitational community. The void galaxies have none of this. Their nearest neighbors are so far away that gravity barely connects them, that interactions are so rare as to be effectively absent over the lifetime of the universe. They evolve alone. They form their stars alone. They consume their gas alone. They change, slowly and quietly, with no outside influence pushing them toward anything they would not naturally become on their own. In one sense, this is enviable. There is a kind of purity to it. No collisions, no distortions, no violent interactions to disrupt the quiet processes of stellar birth and death. Just a galaxy, being what it is, at its own pace, undisturbed. Every galaxy they see now seems remarkable, each one a collection of billions of stars, each star a nuclear furnace burning hydrogen into helium and helium into heavier elements. Each system of planets a potential stage for the drama of chemistry and complexity that, on at least one world that we know of, eventually produced something that could look back at the universe and be astonished by it. Every galaxy is an improbable thing, an enormously improbable thing, given the alternative that the void represents, the possibility that the universe could simply not have bothered, could simply have left that region of space empty and cold and eventless. But it did not leave it entirely empty. There were galaxies in the void, however few. And there are galaxies here, at the far edge, growing more numerous as the traveler moves beyond the void's influence. The universe, in the end, is on the side of structure. It tends toward complexity, tends toward gathering, tends toward the slow and patient construction of something from the raw material of matter and energy and time. The void was the exception. This, the re-emergence of the web, is the rule. The traveler stops one more time, just past the boundary region, and looks back. The void is behind them now. From this side, it does not look like anything dramatic. It is simply a region of the sky where the galaxy density thins out. You would have to know what you were looking at to understand its significance. You would have to know that in the direction of the constellation Eridanus, behind the faint galaxies visible at the void's edges, there is a billion light years of near nothingness, a region that has been empty for most of the age of the universe, a place where the cold spot lives in the ancient light, where the standard model strains at its own boundaries, where one of the deepest puzzles in modern cosmology quietly resides. From the outside, it looks like space, just space, with fewer galaxies. But the traveler knows what is inside it. They have been inside it. They have crossed it and been changed by it, and emerged from it carrying the particular quality of attention that only a crossing of that kind can produce. They have visited one of the most extraordinary places in the observable universe, and they carry it with them now, the way all significant journeys are carried, invisibly, inwardly, as a changed relationship with everything that comes after. They turn away from the void. They move on into the fuller regions of the universe, into the web of filaments and clusters, and the ordinary, extraordinary abundance of galaxies that fill most of the cosmos. They carry the void with them, as a memory, as a perspective, as a recalibration of what normal means and what remarkable means, and what it is like to exist in a universe that contains both the full and the empty, the bright and the dark, the crowded and the utterly, almost perfectly alone. And we, following at a distance, carry it too. We have been in the void tonight, in the only way we can be, in imagination, in the slow, patient attention of a long and quiet night. And something of it will stay with us. The scale of it, the silence of it, the strange and unexpected comfort of it. The reminder that the universe is larger and more varied and more extraordinary than any single description of it can capture. The traveler moves on, and we breathe, and we rest, and we let the void settle into us like something that has always been there and has only just been named. If the universe were music, what would the Eridanus Supervoid sound like? This is not a scientific question. There is no sound in space, in the conventional sense. Sound requires a medium to travel through, and the near vacuum of interstellar and intergalactic space provides none. But the question is worth asking anyway, because music is one of the oldest and most powerful ways that human beings make meaning of abstract experience. And the experience of the void, vast and atmospheric and deeply strange, seems to call for the language of sound. Think about how music uses silence. In a piece of music, silence is not the absence of the music. It is part of the music. The rests written into a score are as deliberate and as meaningful as the notes. A pause before a chord resolves can create more tension than the chord itself. A long silence after a climax can be more powerful than any continuation of the sound. The silence is not nothing. It is where the music breathes, where it gathers itself, where the listener is given space to feel what has already happened before the next thing begins. Great composers understood this. They understood that what you do not play can matter as much as what you do, that the space around sound gives sound its shape, the way the space around a sculpture gives the sculpture its form. Silence is not the enemy of music. It is its partner. It is what makes the music audible at all. Now bring that idea to the cosmic scale. If the filaments and clusters of the cosmic web are the music of the universe, the bright passages, the dramatic moments, the crescendos of matter and light, and the drama of stars and galaxies doing all the things they do, then the Eridanus Supervoid is the rest, the long, patient rest written into the score of the cosmos, the silence that stretches for 1 billion light years, that holds its breath while the universe continues its music on either side of it, that gives the surrounding structure its shape, and its meaning by providing the contrast of its emptiness. A universe without voids would be like music without rests, an unbroken wall of sound, with no space for anything to breathe, no contrast to make the loud passages loud or the quiet passages quiet. The voids are necessary, not in the sense that someone planned them, not in the sense that the universe intended them to serve this purpose, but in the sense that the pattern of the universe, the cosmic web, cannot exist without its complement of empty spaces. The filaments are only filaments because the voids are voids. The clusters are only clusters because they stand against a background of relative emptiness. The music is only music because the silence is there. The Eridanus Supervoid, then, is not a flaw in the score. It is not a mistake, not a missing passage, not a place where the composer forgot to write notes. It is the longest rest in the symphony, the most sustained silence, the place where the music holds its breath for the longest time, where the pause is so extended that you begin to wonder if the music will ever return, and then, gradually, it does. The galaxies reappear at the edges. The filaments reassert themselves. The cosmic web continues its intricate pattern, but the rest has happened, and you cannot unhear a rest. It has changed the music around it. This is part of why the void feels eerie, in the way that the best kind of eerie feels. Not frightening in the way of danger, but eerie in the way of the uncanny, the slightly off, the thing that is in the right place, but not quite in the right way. An extended silence in music can feel eerie, not because anything is wrong, but because it is unexpected, because you were following the music and then the music stopped, and the stopping was, for a moment, disorientating. And then, when the music returned, everything felt slightly different, slightly more charged, slightly more significant. The void is the long silence of the universe in this region, and it is eerie in exactly that way. Not wrong, just deeply, unexpectedly quiet, and the quiet reconfigures everything around it. There is also the question of what the void sounds like if you imagine translating its physical properties into sound directly. Cosmologists have actually done something like this, not with the Eridanus Supervoid specifically, but with the acoustic oscillations of the early universe. In the first 380,000 years after the Big Bang, the universe was a hot, dense plasma, and sound waves traveled through it. Pressure waves driven by the competing influences of gravity, pulling matter together, and radiation pressure pushing it apart. These waves left their imprint on the distribution of matter in the universe, and we can see their signature today in the cosmic microwave background and in the spacing of galaxy clusters. The universe, in its earliest phase, was literally ringing. It had a sound, a deep, slow, cosmic sound, propagating through the plasma of creation. The Eridanus Supervoid, in that primordial music, would have been a quiet region, a place where the plasma was less dense, where the sound waves were weaker, where the oscillations were smaller. Not silent, even then, but quieter than average. A region that was, from the very beginning, inclined toward the quiet, that tended, when the universe was still forming its first structures, toward the understated and the sparse rather than the emphatic and the dense. In a sense, the void has always been the quiet part. Its quietness is not something that happened to it later. It is something that was present from the beginning, in the tiny fluctuations of the early universe, in the slight underdensity of the region that would eventually grow, over billions of years, into the supervoid we observe today. The void silence has ancient roots. It has been becoming itself, slowly and patiently, for almost the entire age of the universe. And when we listen to it now, in whatever way listening applies to something we can only observe and not hear, we are hearing something very old. The quietness of a region that has been tending toward quiet since the first moments of everything. The silence of a place that has had almost 14 billion years to perfect its emptiness. There is a particular quality to very old silences. to the silence of an abandoned building that has been empty for a century, to the silence of a landscape that has not been visited in living memory, to the silence of a cave that no one has entered in thousands of years. These silences are different from the silence of a new room or a fresh space, or an emptiness that is only recently empty. They have weight, they have texture, they carry within them the accumulated time of their own duration. The silence of the Eridanus Supervoid has that quality, amplified to a cosmic degree. It is a silence with almost 14 billion years behind it. A silence that has been itself for longer than Earth has existed, longer than the sun has burned, longer than any of the elements in your body have been assembled in their current form. It is, in the deepest sense, an ancient silence. And there is something about ancient silences that we respond to, even when we encounter them only in imagination. They invite a corresponding quiet in us. They ask us to stop making noise, to stop filling the air with our own sounds and thoughts and concerns, and to attend to the silence itself, to let it be present without immediately replacing it with something. This is what the void is doing tonight. Through the medium of these words, through the image of that billion light-year silence, through the slow and patient accumulation of the story we have been building across this night, it is inviting you to become a little quieter, to let the mental noise drop a little, to find, in the contemplation of something very large and very still, a corresponding stillness in yourself. Not the stillness of emptiness. You are not empty. You are full of everything that makes you who you are, full of your history and your relationships and your questions and your particular way of experiencing the world. The void is not asking you to become nothing. It is asking you to become quiet, to let the noise settle, to discover what is there when the usual clutter falls away. The universe has placed this enormous silence in the direction of Eridanus. It has held it there, stable and patient, for billions of years. And tonight it is available to you, as a reflection, as a companion, as a long and restful note held at the edge of hearing. Listen to it. You do not need to hear anything in particular. You only need to let the silence be present, the way music lets the rest be present, as a meaningful part of the whole, as the breath between the notes that makes the notes what they are. The void plays its long, patient rest, and the symphony of the universe is richer for it. Science does not study things only because they are beautiful, though beauty matters in science more than is sometimes acknowledged. The feeling that a theory is elegant, that it fits together with a rightness that goes beyond mere correctness, has guided physicists and cosmologists toward truth more than once. Beauty is not a guarantee of truth, but it is a signal worth attending to, a hint from the universe that you might be asking your questions in the right language. But the Eridanus Supervoid matters scientifically not primarily because it is beautiful, though it is, in its eerie and atmospheric way, beautiful. It matters because it is information. It is a data point of extraordinary size, one of the largest and most anomalous single features in the observable universe, and data points of that kind are not to be ignored. They are to be understood, and the effort to understand them has a way of pulling the rest of knowledge forward. Let us think, then, about what the void actually tells us, about what scientific questions it bears on, and why those questions are among the most important that cosmology is currently asking. The first thing the void tells us is something about the initial conditions of the universe. The structure of the cosmic web that we observe today, with its filaments and clusters and voids, is the product of a process of amplification. The tiny fluctuations in the density of the early universe, the quantum ripples that inflation stretched to cosmic scales, were the seeds. Gravity amplified them over billions of years into the structures we see. The statistical properties of the structures we observe today, therefore, carry information about the statistical properties of those original fluctuations. The Eridanus Supervoid, in its extreme size and emptiness, is a particularly loud data point in this statistical picture. It says something about the tail of the distribution of initial fluctuations, about how extreme the underdensities could be in the very early universe. If the void is consistent with the standard model, that tells us our model of the initial conditions is robust. If it is inconsistent, if it is too extreme to be explained by the fluctuations our model predicts, that tells us something important is missing from our understanding of the initial conditions. Both outcomes are scientifically valuable. Confirmation tells us we are on the right track. Contradiction tells us where to look for new physics. And the void, right now, sits uncomfortably between these two outcomes. Large enough to be troubling, but not so definitively anomalous that it has forced a revision of the standard model. It is in that most productive of scientific positions, the anomaly that keeps pressure on the theory without yet breaking it. The second thing the void tells us is something about dark energy. We have touched on this already, in the context of how voids grow under dark energy's influence. But the connection runs deeper than growth rates. Dark energy is, at present, almost entirely characterized by a single number, its energy density, which determines how strongly it drives the acceleration of the universe's expansion. We know this number from several different observations, most importantly from measurements of distant supernova and from the pattern of the cosmic microwave background. But these measurements give us an average value, a global property of dark energy across the entire observable universe. What we do not know is whether dark energy is truly uniform, whether it is the same everywhere, or whether it has spatial variations, regions where it is slightly stronger or slightly weaker than average. The standard model assumes it is perfectly uniform, but this assumption has not been definitively tested at all scales and in all environments. The Eridanus Supervoid is a place where this assumption can be tested in a particular way. If dark energy is perfectly uniform, the void's growth and properties should match the predictions of the standard model, modulo the statistical anomaly of its extreme size. If dark energy varies spatially, the void might behave differently from predictions, growing at a rate or to a size that the uniform dark energy model cannot accommodate. By comparing precise observations of the void with detailed simulations run with different dark energy models, cosmologists can look for deviations that might reveal the spatial variability of dark energy. This is not a test that can be done quickly or easily. It requires very detailed observations of the void's structure and the distribution of galaxies within and around it, observations that are at the edge of what current instruments can achieve. But future surveys, including the Euclid satellite launched by the European Space Agency and the Vera C. Rubin Observatory's Legacy Survey of Space and Time, will map the universe's large-scale structure with unprecedented precision and depth. The Eridanus Supervoid will be one of the targets of this new generation of observations, and the data they produce will sharpen our understanding of what the void is telling us about dark energy. The third thing the void tells us involves the cold spot, and through the cold spot, the possibility of physics beyond the standard model. We have established that the supervoid can account for some, but not all of the temperature deficit in the cold spot, that there is a residual anomaly that the void alone cannot explain. This residual could be statistical, a combination of measurement uncertainties and the natural variation of the cosmic microwave background that, when combined with the supervoid's contribution, happens to look more anomalous than it really is. But it could also be physical. It could be the signature of something that the standard model does not include. If the cold spot's excess anomaly is real and physical, the possibilities include the collision with a bubble universe, which we have discussed. But they also include more prosaic extensions of the standard model, modifications to the physics of inflation, the presence of additional light particles in the early universe, departures from the standard cosmological model in the void region itself. Each of these possibilities makes predictions that future observations can test. And the cold spot, with its persistent refusal to be fully explained, is one of the most powerful motivators for those tests. In this sense, the Eridanus Supervoid is doing what the best scientific anomalies always do. It is not just a puzzle. It is a driver. It is pushing cosmology toward better instruments, better simulations, better theoretical frameworks. It is insisting that the field takes seriously the possibility that the standard model, for all its extraordinary success, is not the final word. That there are things in the universe, and the supervoid is one of them, that require us to think harder and look deeper and be willing to revise our understanding when the data demand it. The fourth and perhaps most fundamental thing the void tells us is something about the nature of the universe's largest scales. Cosmology operates on the assumption, called the cosmological principle, that the universe is, on the largest scales, homogeneous and isotropic, that it looks roughly the same in all directions and from all locations. This assumption underlies virtually all of our models and calculations. Without it, cosmology as we practice it would be extremely difficult, because we would have to account for the specific location and orientation of every observation we make. The cosmological principle is well supported at the very largest scales, those of the observable universe as a whole. But it is an approximation, not an exact truth, and it breaks down at smaller scales, where the actual inhomogeneity of the universe, its galaxies and clusters and filaments and voids, is evident. The question is at what scale the cosmological principle becomes an accurate description. How large does a region of the universe have to be before its average properties converge on the universal average? The Eridanus Supervoid, by being so large and so anomalous, is a stress test of this question. It is a region of almost 1 billion light-years where the local properties, specifically the density of matter and the temperature of the cosmic microwave background, are significantly different from the universal average. If regions this large can deviate this significantly, that tells us something about the scale at which the cosmological principle applies and about the range of variation that exists even at very large scales. Understanding this is not merely academically interesting. It has implications for how we interpret all of our cosmological observations, which are always made from a specific location in the universe, specifically ours, and are always subject to the possibility that our location is not perfectly representative of the universe as a whole. The void is a reminder that location matters, that where you are in the universe affects what you see and how you interpret it, and that building models that are truly universal requires understanding the range of local variation that the universe actually contains. All of these scientific questions, initial conditions, dark energy, beyond standard model physics, the cosmological principle, are among the deepest questions in contemporary cosmology. And the Eridanus Supervoid has a stake in all of them. Not because it was designed to, not because the universe arranged it for our benefit, but because extreme things, by their extremity, tend to bear on extreme questions. And the supervoid is about as extreme as the observable universe gets in the category of emptiness. It matters because it is anomalous. It matters because it is large. It matters because it sits at the intersection of the most important questions we are currently asking. And it matters because the answers it eventually helps us find, however long that takes, will teach us something fundamental about the universe we inhabit. For now, the void keeps its silence. The cold spot persists in the ancient light. The questions remain open, and the night is still and deep and patient, like the void itself. The traveler has been thinking about what they will say when they return, not about the science. The science can be recorded, reported, analyzed, added to the body of knowledge that this crossing has generated. Measurements of galaxy density, careful logs of the instrument's readings, the accumulated data of 1 billion light-years of observation. All of that will be valuable. All of that will contribute to the ongoing effort to understand what the void is and what it means and why it exists. But the science is not what the traveler is thinking about. They are thinking about how to explain what it felt like, how to convey to someone who has never been inside the void, who has always lived in the fuller, brighter, more populated parts of the universe, what it is to spend an immense amount of time in a place where almost nothing exists. How to put into words an experience that is, in its most essential quality, about the absence of things that words usually describe. How do you describe emptiness to someone who has never been inside a truly great one? You start, perhaps, with what it was not. It was not frightening, or not in the way that fear usually works. Fear, in the ordinary sense, requires a threat, something approaching, something with intentions that might not align with your own. The void has no intentions. It is not approaching. It is simply there, in all directions, patient and indifferent. Whatever unease it produces in the contemplation of it comes not from what it might do, but from what it is. From its scale, from its demonstration that the universe can contain such absence. Fear of the void, if that is even the right word for it, is more like awe than like danger. And it was not lonely, exactly, or not in the way that loneliness usually feels. Loneliness, in the human sense, is an ache of separation, the feeling of needing connection that is not available. But connection, human connection, was never available in the void in the way it is not available anywhere in the depths of space. The void is not lonelier than any other region of the deep universe. It is simply vast, and the vastness makes the absence of everything else more visible, more undeniable, more present as a fact rather than as a feeling. What it was, the traveler decides, was clarifying. Spending an enormous amount of time in a place with nothing to look at, nothing to respond to, nothing demanding attention from any direction, clarifies something. Not in the sense of solving problems or answering questions, but in the sense of stripping away the noise, of reducing the universe to its most minimal form, and in that reduction, revealing something about what remains when everything superfluous is gone. What remains is attention itself, the capacity to be present in a place, to notice that you are there, to observe even when there is almost nothing to observe. The void does not offer anything to the traveler, but in offering nothing, it returns the traveler to themselves, to the simple, irreducible fact of their own awareness moving through space and time. This is, the traveler realizes, what meditation has always pointed toward, what every tradition of contemplative practice has tried to describe in its own language. The stripping away of stimulation until what remains is awareness itself, present and alive and not dependent on what surrounds it for its essential quality. The void is the universe's version of that practice, an enforced, cosmic, billion-light-year retreat into nothing, from which the one who crosses it emerges with something they cannot quite name, but can feel the weight of. Now they are past the edge. The galaxies are thickening around them, not densely yet, not in the way of a cluster or a filament, but increasingly present, increasingly real. The universe is returning in its full and complicated abundance, and the traveler is moving through its return with a quality of attention that they did not have when they entered the void from the other side. Everything looks slightly different on this side. They know, in a way they did not before, that this abundance is not inevitable, that the universe could have arranged things differently here, could have left this region as empty as the void they crossed, and the cosmos would have gone on without it. These galaxies, these stars, whatever planets orbit them, whatever complexity might have arisen or might arise or might already be looking back from somewhere in that scatter of light, none of it was guaranteed. None of it was the default. The default is the void. The exception, the improbable achievement, is all of this. And perhaps that is the deepest thing the crossing has taught. Not a lesson about physics, not a lesson about the statistics of voids or the mechanics of dark energy or the mysteries of the cold spot. A simpler lesson, a more personal one, that existence is not the baseline, that presence is not guaranteed, that the fact of there being anything at all, any galaxy, any star, any planet, any life, any awareness, any consciousness able to look at the universe and find it beautiful and be moved by its scale and feel something in the face of its emptiness, is not the expected outcome of a universe that could so easily have simply arranged for more void. Existence is the exception, and the exception is everything. The traveler looks back one more time. The void is still there, behind them. It will be there long after they have gone, long after any record of their crossing has faded, long after anything we could call civilization has risen and declined and been forgotten. The void will endure, patient, quiet, almost empty, the long rest in the symphony of the universe. They look forward. The galaxies ahead are ordinary in the way that all galaxies are ordinary when viewed without context. But the traveler has context now. They have crossed 1 billion light years of the universe's most extreme quiet. And that context makes every galaxy a kind of miracle, not in the supernatural sense, in the more precise and more profound sense of something that happened against enormous odds. Something that required the specific and unlikely combination of initial conditions and physical laws and the long patient work of gravity and time to produce. Something that, given the evidence of the void, did not have to be here at all. And yet it is here, and the traveler is here, and they are looking at it, and they are grateful in the particular way that only the experience of true emptiness can produce genuine gratitude. Not grateful in a performed way, in the deep, quiet, unexpected way of someone who has just returned from a very long journey through a very empty place, and has found, on the other side, that the ordinary world is far more extraordinary than they remembered. We will all return, tonight, from our own version of this crossing, not a literal crossing, not through actual space, but through the imagination, through the dark and patient spaces that open up when the noise of the ordinary day is set aside and something larger is allowed to be present. We will return to our rooms, our beds, our ordinary lives, with perhaps a little of what the traveler carries. A recalibrated sense of scale, a renewed awareness that existence is not the default, a quiet gratitude for the improbable fact that the universe, in this corner of itself, arranged for something rather than nothing. The traveler moves forward into the ordinary, extraordinary abundance of the cosmic web. Behind them, the void keeps its ancient silence. Ahead of them, the universe continues its long and complicated song, and they carry both, the silence and the song, the empty and the full, the nearly nothing and the everything. All of it, now, part of them, the way every significant journey becomes part of the one who makes it. They are changed, and in being changed, they are more fully themselves than they were when they began. We have come a long way tonight, from a quiet room somewhere in the world, wherever you are, whatever time it is as these words reach you. We have traveled together to one of the most extraordinary places in the observable universe. We have crossed, in imagination, the Eridanus Supervoid. We have sat at its edges and felt its immensity. We have moved through its near-nothingness. We have met the few lonely galaxies that exist within it and wondered what it might be like to look out from one of them into the surrounding dark. We have asked the questions that the void asks. What made it? What is inside it? What does its coldness in the ancient light reveal? What does its existence mean for our understanding of the universe and of ourselves? And now we are returning. The journey is ending. The dark is becoming the comfortable dark of a room at night, the darkness of a familiar place rather than the darkness of 1 billion light years of empty space. The void is receding behind us, the way all journeys recede when they are over and you are finally home. Let us sit, for this last part, with what the void has to offer us not as a scientific object, but as an experience. With what it feels like, from the inside of a quiet night, to have spent time contemplating something this large and this empty. The first thing it offers is perspective. This is the most obvious gift of any encounter with the cosmic scale, and it is never less true for being obvious. The Eridanus Supervoid is approximately 1 billion light-years across. In the context of that number, every human concern, every problem, every anxiety, every uncertainty is small. Not meaninglessly small, not negligibly small, but small in a way that can be felt rather than merely understood when you have spent time genuinely trying to comprehend that scale. The void does not solve any problem. It does not make any difficulty disappear, but it does relocate the difficulty. It places it in a frame that is much larger than the difficulty itself, and in that larger frame, many things that felt enormous become not nothing, but not everything either. This is a comfort, not the comfort of making problems disappear, the comfort of proportion, the comfort of knowing that you and your difficulties are embedded in something so much larger that the ratio between your largest worry and the void is more extreme than the ratio between a grain of sand and the observable universe. Your worry matters. You matter, but you are not the whole story, and the whole story is very large. The second thing the void offers is silence. We have talked about this extensively tonight in different ways and from different angles. But silence, as a gift to bring back from a night spent contemplating the void, is worth naming directly. We live in a world of noise, not just the literal noise of engines and voices and screens and the thousand sounds of modern life, though that noise is real and constant. The noise of information, of obligation, of the relentless pressure to be attending to something, responding to something, producing something. The noise of a self that is always performing, always narrating, always telling itself the story of its own experience in real time. The void has no noise. It has almost nothing in it. And in spending time with it, even imaginatively, even at the remove of words in the dark of a quiet night, something of its silence can be borrowed, something of its patience, something of the quality of attention that comes from a place where there is nothing to attend to, and attention therefore rests in itself. You are already quieter than you were when this night began. If you have been listening, if you have let these words carry you through the void in whatever way they could, you have been practicing a kind of stillness. The stillness of following a thought without needing to produce one. The stillness of receiving rather than generating. That stillness has been accumulating, slowly, over the course of this long journey. And it is here now, in you, in whatever measure the night and your particular readiness for it have allowed. This is the void's gift to you tonight. Not an answer, not an explanation. Silence, and the space that silence opens. The third thing the void offers is something stranger and harder to name. It is the comfort of knowing that nothingness is possible. This might sound like a dark thought, but I mean it as a reassuring one. The Eridanus Supervoid exists. The universe contains, within its ordinary fabric, a region of near nothingness that has persisted for billions of years. Nothing catastrophic has resulted from this. The universe has not ended because one of its regions is almost empty. The galaxies surrounding the void are not in distress because of their proximity to it. The cosmic web continues to exist, continues to evolve, continues to produce complexity and structure and light, all around the edges of this enormous quiet place. Nothingness, it turns out, is survivable. The universe survives it. The cosmos contains it, incorporates it, makes it part of the pattern, and goes on. The void is not a wound that needs healing. It is a feature. It belongs. And perhaps there is a lesson in that for the spaces of emptiness that we encounter in our own lives. The quiet periods, the transitions between things, The times when the usual structures of occupation and purpose and connection are absent or reduced. These can feel like voids, like places where normal life has thinned to near nothingness, where the expected density of event and meaning and engagement is not met, where you float in a kind of personal emptiness that is disorienting precisely because the fuller life exists on either side of it as a comparison. The Eridanus Supervoid suggests that these periods of emptiness are not failures. They are features. They are part of the pattern. They have their own function, their own value, their own particular quality of presence that is different from the fuller times, but not lesser. The void is not lesser than the filaments around it. It is different. It contributes to the whole in a different way, as contrast, as balance, as the space that gives the surrounding abundance its shape. Your quiet periods are like this. They are not voids in the sense of worthlessness. They are voids in the sense of the universe. Necessary, part of the architecture, the rest in the score that makes the music possible. The fourth gift of the void, and perhaps the deepest one, is wonder. Wonder is not a simple emotion. It is not happiness, exactly, though it can produce happiness. It is not awe in the sense of overwhelm, though it contains that. Wonder is the state of being genuinely, deeply surprised by reality, of encountering something that your expectations could not have predicted, something that your ordinary categories cannot quite contain, and responding to that encounter not with the anxiety of the unknown, but with the particular aliveness of the genuinely astonished. The Eridanus Supervoid produces wonder. It has produced wonder in every scientist who has seriously engaged with it. It produces wonder in us, tonight, as we contemplate its scale and its mystery and its cold spot and its loneliness and its question marks. It is one of those places in the universe that the universe has arranged, without any intent or purpose, to produce precisely this response in the kind of thing that is capable of having it. In us, in the aware, wondering, meaning-making creatures that the universe has produced in its fuller, brighter, more galaxy-rich corners. We are, in a certain sense, the universe's way of being astonished at itself. We are the mechanism by which the cosmos contemplates its own extremes. We look at the void and we feel wonder, and in feeling wonder, we are doing something the void itself cannot do. We are seeing it, not just detecting it, not just measuring it, but seeing it in the fuller sense of bringing it into the dimension of significance, of meaning, of the experience of being astonished. The void, in its near nothingness, has produced this, has been the occasion for this, and that is extraordinary. So let the wonder settle into you as the night deepens. Let the scale of the void be present in you as a felt thing rather than merely a known thing. Let the cold spot in the ancient light be a mystery you are comfortable sitting with rather than one that demands immediate resolution. Let the lone galaxy you imagined inside the void be a companion of a kind, a reminder that even in the most barren places, something persists. Let the traveler's journey be yours for this moment. They crossed 1 billion light years of empty space and emerged changed. We have crossed it in imagination, which is smaller but not nothing. We have been changed, in whatever small way this night has changed us, by the encounter with something very large and very quiet. And now the void is behind us. The night is still. The room is warm. Your breath is slow. The universe is 13.8 billion years old, and it contains, among its hundreds of billions of galaxies and its countless stars and its incomprehensible variety, one particular region called the Eridanus Supervoid, 1 billion light years of near nothingness, a cold whisper in the oldest light, a question that our best theories cannot quite answer, a silence that has been keeping its silence for most of the age of everything. And tonight, for this brief moment, you knew it was there. You traveled to it in the only way a human being can travel to something 1 billion light years away. You brought your attention to it. You let it be present. You let its scale and its strangeness and its patient, ancient quiet do whatever they could do in the space of a night's listening. That matters, not to the void, which cannot know that it has been visited, but to you, and to the particular quality of the awareness you carry into whatever comes next, into sleep, now, and into tomorrow, and into all the ordinary, extraordinary days that make up a life embedded in the cosmic web, surrounded by 400 billion stars, on a small warm world orbiting a middle-aged sun, in a galaxy that is itself embedded in something so large that comprehending it requires most of a night and still leaves most of it uncomprehended. Sleep now. The void is patient. The cold spot will persist in the ancient light until instruments more sensitive than any we currently have read its full meaning. The questions will wait, as all the best questions wait, for the minds that are ready to answer them. Tonight you have been in the presence of something immense and quiet and strange and beautiful. And that is enough. That is, by any measure, more than enough. Let the silence of the void carry you down into the deep, warm quiet of sleep. Let the darkness around you be not the darkness of emptiness, but the darkness of rest. Let the ancient light, still traveling in every direction through every corner of the universe, including wherever you are right now, be a kind of company. A reminder that even in the dark, something is moving. Something is there. Something has been there since almost the beginning, and will be there long after everything we know has changed beyond recognition. The void is quiet. The universe is old, and you are here, warm and breathing. Part of the pattern, part of the web, part of the extraordinary, improbable abundance of a cosmos that could so easily have arranged for more nothing and instead arranged for you. Rest now. The Eridanus Supervoid will keep its silence. And in that silence, carried gently into sleep, you will find that the quiet of the void and the quiet of a resting mind are not so different after all. Both are a kind of return. Both are the place where everything that is not essential falls away, and what remains is simply this. Simply here. Simply the deep, patient, ancient fact of being. Good night. Sleep well. The void is watching over you, in its vast and empty and entirely indifferent way, and that, tonight, is comfort enough.